Hello, good afternoon, Dr. Azam and Architect Sali. Myself, Sunida, and Mustaqim, Nick Aidil, Adila, Nurin Kis, and Nurul Nadia are from Group 2, Energy Efficiency. And next, we'll be presenting introduction on the GBI and going into the introduction on our case study, Mercu Alam Bina. And thirdly, we'll be talking about our refurbishment proposals. And lastly, assessing the refurbishment proposals before and after. So firstly, as we all know, the Green Building Index, GBI, is Malaysia's industry-recognized green rating tool to promote sustainability in the built environment and provides an opportunity for us to design and construct green, sustainable buildings. And next. So under the GBI, energy efficiency talks about improving energy consumption by optimizing building orientation, minimizing solar heat gain, harvesting natural lighting, and adopting best practices in building services, as well as ensuring proper testing, commissioning, and regular maintenance. So our aim in this study is to achieve all this in the Mercu Alam Bina. So I'll pass to my group mates to talk about our case study.
So as for introduction of the building, the Faculty of Built Environment is designed by Surya Architects and implemented artistic and green concept. FBE also offers professional programs tailored to meet the nation's construction and real estate sectors manpower needs. All these programs are accredited at the national and international levels. So the existing features that can be found at FBE, which is the first image, which is the atrium. It is functioned as a breathing space for students and staff to enjoy and avoid sick building syndrome. At second image, the architect encourage the public to use staircase than the lift to keep them healthy and fit. So they design a natural ventilated staircase, and the building also is designed to be easy to maintain. So they design a big windows so that easy to clean. And then they implemented double skin facade to avoid glare. So next.
I'm sorry, Adila, are you there?
Sorry, the screen still changing. Okay, yeah. So for the existing building services, we'll be able to detect that there are lift core at the entrance of the Mercu Alam Bina, where there are 3 lifts provided, including 1 bomba lift for vertical transporting people and goods from one floor to another. So the control room located at Aras 2, which is an entrance and exit for the back. The second one is for the artificial lightings. The diagram shows that the lighting fixtures are connected at every floor and are connected with the risers vertically. For the firefighting system, the building is well equipped with passive fire protection system, and the evacuations are at the ends of the building and including at the center, where the ends of the staircase are an open ventilated system where there are no needed mechanical ventilations for it. So they are provided hose reel and also fire extinguisher along the floors. As for electrical and water supplies, there are water tank and TMB substation located at RS2, where it is at the entrance and exits for the Mercu Alam Bina building. Next. So as for the GBI index data, this is the data that we'll be able to collect it as for now. So for the EE1, which is the program using OTTV, and the solution are to use a white paint, tinted change to bronze tempered to flute glass, and also for the lighting zoning, the existing is lighting is zoned by individual switch, and also the using of energy efficient LED and T5 lighting, motion sensors, and new proposal of using daylight photo sensors installations. As for EE3, there will be installed network meters for submetering of energy for every floor. As for EE4, to propose a new solar panel energy, which is 300 NOS for solar panels and 1 micro hydro power turbine. And for EE5, the GBI that we have collected, that the existing is 970.6 kilowatt per year. And EE6 is the appointing commission specialized, which is CS, and EE7 is the solution is professional engineering and CS as verifications. And the last one is EE8, which EE monitoring and improvement, where the solutions is to commission the maximum demand limiting program, and also to utilize EMS to monitor energy consumptions. Next.
For minimum EE performance, which is EE1, is the intent is to create energy efficiency awareness and to promote the use of MS 1525. Okay, next. So what have been implemented is first is to replace windows with low shading coefficient value, which is that we have been using a bronze tinted, bronze tempered float glass, and also to paint white to reduce the solar heat gain by reducing the solar absorptivity of value. So next. The table shows the OTTV value of existing building. This is actually the estimated. Currently, we calculated that it is 79 watt per meter square of the OTTV value with the alpha, because the existing building is currently using a dark gray paint. So the alpha value of the paint is high, which is 0.8. And then the SC, the shading coefficient of the glazing is quite high, which is 0.94. So next, moving to the what we have implemented is the proposed OTTV calculation. This is actually after we paint it white, so the alpha value of the color is reduced to 0.3, and also the shading coefficient of the glass is reduced to 0.6, and calculated that the OTTV value of the new building of the new Alambina is 49.63 watt per meter square, and we obtain 2 GBI points. So this is the value, the coefficient value, the shading coefficient value of the bronze tempered float glass. So next is Adila.
Okay. As for EE2 lighting zoning, Mercu Alam Bina collect 2 points as for the existing, which is the intention to provide flexible lighting controls as to optimize energy savings. So the existing is 2 points, and the third point is that we would like to propose a new lighting zoning systems for the Mercu Alam Bina. So next. Is the slide changing?
I'm showing the Photoshop
Okay. As you can see here, the green one is system where occupancy sensor controls would like to be installed, where it can save up to 35% energy saving from energy consumptions. And the new proposal that we like to propose is the photo sensor controls, where it can prevent outdoor lighting from operating during daylight hours. It actually can save 35 to 45% energy saving according to our reference. So therefore, the total amounts of GBI points obtained is 3. And for the lower part is the diagram where shows the where it be able to operate whenever there are motions or people inside spaces. Next.
So moving on to the electrical submetering, we propose a submetering system for the building. The intention is to actually monitor the energy consumption of the building. So it encouraged the tenants, the users to be more considerate using the electrical. So we gain 1 point, 1 GBI point for using a submetering system.
Sorry, just 1 minute left here.
All right, thank you, Rena. So by using this system, it can reduce the amount of electrical usage by 15% estimated. We also proposed the idea of splitting measuring the monitoring the energy usage per floor, so it will be much easier to monitor each floor. So next.
I'll go quickly on the EE4, which is the renewable energy. So from here, the max point is 5 points, and we actually managed to gain it from the solar panels that we introduced. So from here, since our site, our building is sitting on the highest side of the area, so there's no obstruction of sun. From the 300 proposed solar panels, we arrayed 6 by 30, which is using 0.3 kilowatt peak. And we got a total output of 108 kilowatt peak, which is much greater than GBI requirement of 40 kilowatt peak. This results in 6 GBI point. But to go experimental, we actually did a study on micro hydropower turbine, where we use Pelton wheels, and this can actually generate 8 kilowatt peak depending on rainfall. So we managed to obtain 2 GBI points by putting the turbine on the 9th floor of discharge. Next is BEI. So BEI that we calculated without renewable energy is actually 1450. And even with renewable energy, we got 970.6 kilowatt per hour per meter square and per year. So actually it is very far from the requirement from GBI. So in short, that we can conclude is that Masjid Alam Bina is very low in energy efficiency, maybe due to the unclear building division among new block and old block. And next is EE6, where it's on enhanced commissioning and recommissioning of building energy system. So the approach is to appoint CXS, which is a commissioning specialist from GBI, to implement improvements to ensure buildings measure energy usage, develop a commissioning or ongoing commissioning plan, provide training for management staff, and lastly, to update the building operating plan to reflect any changes of occupancy schedule. So these are the list of GBI competent CSX that we got from the website. And next is EE7, where the intent is to update ongoing post-occupancy commissioning with max of 2 points. And so we have a procedure, we listed a procedure on gaining the first point, where for renovations of FBE building, Syed Daim from FBE Development Unit is to receive the engaged fit-out plans and to submit to the previous professional engineer, which is from DPI Consult. Then he will review it, and when it's carried out and complete, the professional engineer is to verify. So when it's verified and completed, to gain the second point, the appointed CXS will do full recommissioning on the energy-related system, and he or she will verify the original system is performance is sustained. Moving on to EE8, Sunida.
So EA8 aims for the building not just to be built, but to provide also ongoing accountability by energy management system, and also by providing commission for it. Next. So that is all for our building proposals. Go to analysis. Yeah.
We did quickly, we did a building performance assessment on the existing and targeted. So the existing point is still, we need to fully review first. So the targeted points that we managed to get from our proposal is actually 12 out of 35, where we can see a huge loss is being studied here from the BEI observation.
Okay.
Okay, thanks.
Thank you.
Can you go back to that BEI calculation thing? You know, how do you
Macam
manage to
salah
get
lah.
that? Itulah, macam tak betul. 1,000. Nearly 1,000.
You guys kena ingat macam even the most inefficient buildings yang badly designed like glass building, BEI about 400 lah. Worse. Macam
itulah, it's almost like, you know, the largest building on earth kind of thing.
Ada time travel machine ke dalam? Ada some secret mad scientist base that draws energy from the grid.
Dah, sekarang ni kan I think mungkin beginilah. You got the data from the meter kan. I think isu dia mungkin that meter tu is not just covering mercu building tau. You know, it could also be covering the old building as well. And the old building tu pun, it could be the whole of the old building rather than, you know, just one block. Itu tu I think need to get some clarification from the PHB, you know, otherwise we won't be able to get really good data dekat sini.
Yeah, true.
I think the problem lies kat situ kot.
Okay.
We will check. But floor area tak boleh lari jauh. You can't run away very far, right? Floor area, because I mean, unless you scale it wrongly. What's the total? One floor is how much? This, according to your calculation, one floor is what's the footprint area for one floor, for one story?
Mus?
Sorry, it's about 1,700
per meter per floor.
Sounds okay.
Yeah, per floor.
Yeah. I think mungkin tu kot, the energy data tu is not covering just one building though. It's covering, you know, two or three buildings sebenarnya.
Your OTTV calculation, did you show where you get your shading coefficient for the sites and all that? I can't see it just now.
For the shading coefficient, yes, we get it from the please move to the, yes, this one. Next. Yeah, this is from the Golden Ferrous Glass Indian Berhad. The shading coefficient is over 0.64.
No, I mean like with regard to orientation apa semua tu tak ada?
Yang tu sebab sorry, the building is oriented. Actually, it's not facing the north. The shortest edge. So I'm just I agak-agak aja actually because sorry.
I think just show the actual like a diagram where you which value is where, so that you know people can double check easily. Kan, because somebody like who doesn't know the bit, even I am not sure where the sunrise is in Faculty Al-Amin.
It's actually on the front side, dekat pintu masuk lobby.
So I think because the shading coefficient ni they change towards the orientation kan.
Yeah.
Each facade is different. Jadi I think that diagram quite important lah. if you are using the values and how you derive the value, because when you insert that into the OTTV calculation, it can greatly affect your result.
Yeah,
You can you can also refer to MS 1525 ada dalam spektrum tu saya letak.
okay.
Yeah, I think you should be referring to the GBI ni is actually referring to MS 1525 lah, basically.
Okay.
Okay, thank you.
So perhaps you can just correct those two, and then hopefully you can improve even further lah. Okay. Alright, thank you very much. Can we move on to the next group, please? I think timing wise tadi tu not so great lah kan, you know. Tak apa. Next group perhaps you can do better.
Apalah, I think you be as clear as possible lah.
Yeah, of course.
Don't have to elaborate.
Yang kelang kabut.
Don't have to explain everything. I think only the bottom line, the important bottom line stuff.
Alright, second group, please.
Hi.
Hello.
Hi, good afternoon, everyone. I'm Benyu. So we are from group 7. Our group member got Nguyen Wei, Amanda Fu, Hua Xiu Ting, Lo Junyo, Goyo Jiami, and Lim Yong Sing. So we are energy efficiency groups. Next, I will start with the EE ones, minimum energy efficiency performance of OTTV of FBE. Next. So a brief before it, OTTV is under Malaysia standards. So clause number 5, building envelopes. So it defined as the external portions of buildings. So and which the thermal energy is transferred, and the thermal transfer is the major factor affecting the interior comfort level and energy usage. So according to clause 5.2, the OTTV need to be less than 50 watt per meter square. Well, next. The concept of OTTV is calculated with the assumptions of building is completely enclosed, and the item below is not considered. So first, the internal shading device, solar reflections and shading from the adjacent building, and green wall. So the calculations of OTTV as shown below in the additions of heat conduction through wall, heat conduction through windows, solar heat gain through windows. Next. First, we come to the heat conduction through wall. By following the formula, we will have solar absorptivity and U value of the wall. Since the wall color of FBE is dark gray, which means the solar absorptions of wall is 0.58, and the U value of normal plaster brick wall is 2.87. Next. We will come to heat conduction through windows. The value required window to wall ratio, which I will show after the U value of windows. And the U value of window by referring to the Merchant Alam BQ, the window of glass material. Therefore, the glazing type should fall under the single glaze clear type, and the U value is 5.7. Next. Last, we'll come to the solar heat gain through windows. So the shading coefficients can be calculated by the shading coefficient of glass of glazing behind the shading coefficients of external shading device. Next. Since it seems like the FBE do not have shading coefficients of vertical projections, so we only calculate the shading coefficients of horizontal projections. After the calculation by the R1 X divided by Y, so the shading coefficient of external shading device is 0.48. So the total shading coefficient is 0.39 after the calculations. Next. So we will have the window to wall ratio by the every face of the FBE by calculating the total area of wall and windows. Next. So here with the existing OTTV of FBE, the data calculated is different from the last group. So we calculated the OTTV of currently FBE is 54.6, which the OTTV of existing FBE is more than 50 watt per meter square, which means the currently I'm able to achieve 1.4 EE 1 dpi. Next. So as simple, we just propose to lighten the color paint of exterior finish to reduce the overall building OTTB from 54 to 49, so that it complies the recommended OTTB values. Next, thank you.
Thank you, Benio. I'm going to talk about our next proposal, which is the smart energy system. Next. What is a smart energy measurement? Smart energy measurement, it basically use the Internet of Things, or we call it the IoT, to collect and analyze real-time energy consumption data. And for this proposal, we do include smart lighting system, smart energy meter system, and also a smart thermostat system that I'll be explaining deeper later on. And this is a graphical representation of our proposal, and we can see all these system integrated into one of these the typical story of our studio. Next. To start with the smart lighting system, smart lighting system, it coordinates the auto sensors and the lightings together, and they keep the lights off when not required. And we do a little bit study of the lighting zoning. Basically, the lighting zoning, we do it in a linear arrangement whereby it is parallel to the sunlight of the openings. As you can see, for instance, if the light, like in the morning, we do not need to open the artificial light, then we can close all of it. And then when eventually the sun goes up, and then we might need light at this pink zone, then we can just open the pink zone in order to save energy. And there are different types of smart lighting system. For our proposal, we are using the basic lighting controls with dimmers and also the auto sensors lighting. Next. This is a graphic on auto sensors lighting. It's very simple. For instance, when there are no people using the area, it will be off automatically. And when the sensor senses there's motion around, then it will on the lights. This is the way it saves energy. And why is this important? It is important because based on our research, right, for the lighting energy of one building, it basically sums up to almost 29% of the whole building, whereby it is one of the most significant energy consumption of the whole building. Thus, if we can reduce the lighting energy, we can save energy consumption by heaps. Next. We do draft out a lighting zoning for our proposal. This is a typical floor plan for our studio. And if you can see the green area, right, it's the common areas whereby it will make use of the auto sensors, and all the darker blue colors, right, it's basic lightings with control. And the way it arranges like this is because it's just a human psychology whereby these common areas, usually we don't really care about the lights. It's on, and we usually won't care to off it. But with auto sensors, when there's no people around, it will off automatically. Next. We do study a little bit on the types of products available. This is the sensor, and based on the specification, right, it coverage can up to 40 meters, whereby in a typical story of our mature, right, we need around 6 per story, and there will sum up to 10 story of around 30,000 for the product alone. However, in long terms, right, it can save up to 30% of energy. Next. The next one is a smart meter system. A smart meter system records energy usage and communicates this information automatically to TNB itself. And actually, this is a screenshot we have gotten from the TNB website, whereby it actually encourages the use of smart meters. Next. We do have a proposal, like an idea to generate extra income for our studio, whereby we can actually rent out the studio to, since now it's the pandemic era, right, we can actually make use of the empty studios in the mature right now. Whereby how can this be done is that we use the smart meter system, whereby it can do sub-billing, whereby we know each of this parcel, for instance, how much energy they use, and they can pay according to each parcel. Next.
2 minutes left.
This is a smart thermostat system, whereby it basically controls the HVAC. Next. This is to supplement the renting out system that I was mentioning, but it's in terms of the air ventilation. Next. Based on the EE3, right, we can get 2 marks of each based on this category. Next. And ELIT, we can also get two with energy management system applied. Next.
Okay, next I will explain the daylight redirecting film. Next. Okay, as we know, the studio actually we have a large full height window. It's the grabbing the discomfort and direct sunlight at low angle. And another problem is the partition between the student desk blocking the daylight. So the student actually more depend on artificial lighting instead of the natural lighting. Next. Okay, what is the daylight DRF? The DRF actually is a thin acrylic on a flexible polyester film with one side connected with adhesive. It can refract and reflect the 80% sunlight upward to illuminate the inner part of the building 24 to 40 feet. Next. Okay, the advantage of using the DRF is reduce the glare, reduce the direct sunlight, reduce the cooling load, and reduce the artificial lighting. And it also can save the electricity. The benefit between the RDF and the lighting shelf is the RDF is very simple to install and no maintenance needed, and diffuse the light distribute evenly, and it works at all times. Up to 52% lighting energy saving and up to 8 feet of increased daylighting zone for every 1 feet vertically installed from. Next. Okay, this is the DRF can be installed facing the southeast and the northwest of the building. The total DRF can be installed is like 470 meters square. Next. And then the estimated lighting bill saving is around 32%. And we can save around 9,800 kilowatt per hour per month. And estimation is potential maximum cost saving is like 5,000 per month. Next. Okay, actually, this is show how the DRF works. Next. And then this is installation of the RF. Next. And from based on E1, we can achieve 1 point. Next. And E5, we can achieve the minimum, the 2 point. And next.
So I'm explaining about the bifocal lowers. So same problem at the last one. It has a large full height window at the northwest and also southeast facade of the building itself. So by proposing the bifocal lowers is merging a two type of lowers which have front part is reflecting the lights back to the outside, and the inner part will be emitting the lights and diffuse them and make them moving into the inner part of deeper into the room to illuminate the inner part of the room. So the bifocal lowers is you can see that at the right side is how the sunlight in the noon can be reflected most of the direct sunlight, which is uncomfortable for the users that is sitting nearby the windows. However, the invite and welcomes the more smooth light in the morning and the afternoon. So this is the advantage that's quite same as the previous proposal, which to reduce glare, sunlight, and reduce safe electricity on reduce the artificial lighting and also the cooling needs. So there's this product is not much data about it, but we find out that estimation solar transmission reduction is around 45%. So when we compare it with the conventional blinds, it has a lot of advantage. First, it can diffuse the light evenly, so means that when the light pass through the blind itself, it will will be comfortable for the users. So secondly, it also reflect the heat back into the outside, and it is self-regulated, so it is no need to adjust the blind from time to time, so it can reduce the maintenance. And last one, it is no view obstruction, as you see compared on the left side to the right side. The right side is the bifocal lowers. So the total area covered is 1,800. It is same with the previous one. It can reduce the OTTB overall, and also it can improve the BEI on the EE5.
So next I will talk about the we propose the vertical wind turbine next, which under the E4 renewable energy next. Okay, so what is vertical wind turbine? Vertical wind turbine is the wind turbine that are categorized by an axis of rotation that is perpendicular to the ground. So why we choose vertical wind turbine instead of horizontal wind turbine? As vertical wind turbine can operate independently without tracking the wind direction, which is the major advantage for urban application like Mercu Alam Bina located at Kuala Lumpur, where Kuala Lumpur, the wind direction at Kuala Lumpur can change rapidly, and it is more easy to install compared to others type of wind turbine, and it is more quiet to operate as Mercu Alam Bina is a place for education, so the student can are able to focus during the class. And next is the most important thing is it's required smaller space to install, as there are limited space on the rooftop of Mercu Alam Bina. Next. Okay, so there are two types of vertical wind turbines. The first one is Darius wind turbine, and the second one is the Sevenius wind turbine. So Darius wind turbine turns a shaft by using the lift course, while the Sevenius wind turbine is pushed by the direct wind forces. So basically, Darius wind turbine requires energy to start the wind turbine, and when the wind increase and the motor, the power of the motor will turn off, and the wind turbine will work as a generator itself. Yeah, while the Sevenius wind turbine use the cups, they call it a scoop, to capture the wind to generate the yeah. Next. So we use the Quiet Revolution QR6 for our proposal, as QR6 is under the Darius wind turbine, and it produce enough energy to cater the building at a lower or variable wind speed. Yeah, the helical swept beds help to distribute the loads evenly, and this will result in minimal the vibration, and it is a quite good option for the roof. Yeah, to install on the roof. And this QR6 estimated will provide between 5,000 to 11,000 kilowatt per hour per year, depending on the amount of wind at site. Yeah, next. So it's we able to get 3 points for the for this part. Yeah, next.
Okay, sorry guys, so they're over by 6 minutes.
I will just summarize my part. Is it okay, Dr. Azam? Okay, so we propose to have these monocrystalline solar cells. So from here we can see that the efficiency is the highest compared to the polycrystalline and also the thin film. So here is the diagram showing the efficiency of these solar panels compared to other products in the market. We also propose to have these solar panels on the roof of this of our building. Next. So this is one of the product available in the market. So the peak power can go up to 720 watts, and the efficiency is 17%. And then here's the calculation of the electricity usage. So by also calculating the system efficiency loss into the consideration, we can calculate that we actually needed 973.115 kilowatt for the system to produce at the 5 peak sun hours. Next. Besides that, we also propose the BIPV, which is the building integrated photovoltaic solar windows. So this is integrated into our facade of this building. This building here is one of the product available in the market, which is from the brand Shupo. And then this brand actually is very easy. It's just the solar cells are actually sandwiched in between the glass of the facade. Next. So by having the solar panels and also the wind turbine, we can achieve 5 points for the renewable energy. Thank you. Next.
So this is the total E energy, and we can achieve more than 15 parts. Yeah, I think that's all. Thank you.
All right, good. Thank you. Zali, do you have any comments to make? You're muted.
I think, sorry, good presentation. I think a lot of effort have been put, but I think maybe the problem is you're not talking to one another and working in like a silo, because everybody needs to be working on one baseline for like floor area, energy use, because your score is not logical, you see. When one person says you have energy saving of like 52%, then suddenly you score very bad at the advanced or improved EE performance, which is illogical, because if you're doing so well in terms of your product is doing so well, reduces energy, then you should be scoring very high there. You should get a very high BEI. And same thing with, it's just this sort of like mismatch of information. Perhaps I'm not sure where it is, and it's very difficult to say because in your slides you just jump to the result, right? Like, okay, oh, for EE4, because we did this, we got 3 points. So where's the calculation to prove that?
Yeah.
So I think that's quite important lah. And maybe Dr. Azam, maybe everybody should have like they should compile the baseline information that macam as part of the for you to check lah kan nanti.
Yeah, of course.
Easy like what's the floor area for first floor, second floor, third floor, what's the energy consumption for the whole of ni, and what's the assumed rate per square foot or whatever that you're using kan. So all these things need to be agreed upon and everybody talking the same thing, or else macam memang doesn't look logical lah, because the statement on its own might seem like correct when you say one guy says you have a lot of savings, the other guy says we score very low, and like it's very you can't convince us, or you can't, if we are the clients and you are the GBI consultant or architect or whatever, you very difficult to convince me, because like for example when you say this, because NREB is based on improvement, right? So if your BEI is very bad, which a lot of you say is very bad, to improve, they always say that like 1% of the maximum electricity demand. So it's not out of the 10 out of the number given. There's a number given in all these tables, right? Like 5 kilowatt peak, 2 kilowatt peak, 10 kilowatt peak, 20 kilowatt peak, right? Or there's a percentage given, like 25, 5, 1%, 1.5%. So if your BEI, your baseline is bad, the percentage number will always be larger. So it will always be the prime. Do you understand what I'm trying to say or not? Because that's how the tool is made. The tool is made to cater for like if for small project which can use this minimum numbers, or it can be used for large projects which have bad BEI, which use the percentage. So I don't know. I'm not seeing your calculations. So I'm not sure how you get like 1 point, 2 point, 3 points. So you have to justify all this lah. Okay.
So what you guys have to do is, not just this group, okay, perhaps throughout, is to make sure that the how you arrive to the calculation. The calculation is needed. Okay, how do you arrive to the point given? So you do the assessment based on what is existing. And then definitely after that you'll do the improvement lah, of course kan. Okay, then barulah nampak, then only you can see the the flow kan. So get the baseline first. what is the baseline point, the assessment, and then after that, what is the improvement. What I can see now is there's a lot of improvement being proposed, which is great, but we would like to know what is the baseline first. Okay, so apa?
Yeah.
Anything specific you want to point out besides that?
I think specifically the scoring, like if you look, can you just show the summary of the scoring? Because the amount of technology and improvement that you have put in seems like you score very high, but I think the score very low. So macam dia tak make sense, kan?
So like it doesn't commensurate to the amount of points.
Actually, it's like we
can you
not
zoom
so
a bit
sure,
because it's like also small on our screens.
because we're not so sure about the BEI calculations because we cannot get the data of the exact building block itself. So we decided to assume the BEI is below or equals to 2 first. So we just determine the after result of the BEI because we haven't have the correct BEI value. Yeah.
Okay. What your group and the last group have to do really quickly is to contact there's one person at JPHB. Okay. Hopefully he can clear up the in terms of metering, kan. The data is to cover which building. Is it just mercu building ataupun 2 or 3 buildings? If it's 2 or 3 buildings, then definitely you're gonna have to calculate for the rest of the building as well. Can include all of them in somehow? To use that data. Otherwise, we're gonna have to go and do some sub metering later on. I do have monitoring data loggers, kan. Cumanya we need to get electricians to go and fit it. But that requires some approvals here and there. Okay. So if that is the problem, then we're gonna have to go and do some monitoring. So for now, quickly just send an email to, I think, let me find out the name too, for his name. Send an email to him quickly and ask whether or not the data that you get is actually for just one mercu building ataupun the other 2 older buildings as well. Okay. Perhaps it also includes some of the external areas as well. Because for your information, somehow or other the electricity distribution system at the university is rather not to say vague, but sometimes there's some gray areas. I give you an example, at my college over here, our electricity calculation is not just our blocks, you see. It also covers the road and also the road outside our compound.
So all the street lighting pun
is under UM, we am paying for it, somehow or other. So it's really strange. I think because all the wiring was done a long time ago, But in the case of mercu building, they could have extended it from the old building. We have two other old buildings, because those buildings could be connected together somehow or other, right? So I think it's timely if you find out from the engineer, at the PHB, clear things up. Okay.
Yeah. No, that being said, I think imagine all the money you spend. It should have more than the point. The point should be more lah, basically, or else why spend the money, right? Or else you might have to achieve what you achieve. You might as well use some very cheap solution lah. But I think the solutions like your louvers, you change everything and whatnot should give better result.
We actually done the calculation, but we not sure how to sum it up all into one, because our proposal is 4 or 5 proposal is actually contribute to the BEI and also for the EE performance, but we're not sure how to sum it up together to make it become a final EI value.
Oh, okay. So my suggestion is you have okay, the baseline everybody must agree lah, because everybody should be working on the same baseline. Okay, agree? Kan? Yep. Kalau if working on a different baseline tu macam that's problem lah. Yeah. So every baseline is the same. But if you one group has a different BEI than the other group, I think there's no issue to have 2 separate you can mention lah, you are choosing, say for example, if the other groups who are doing other things who are interrelated with you, you can say you're getting from group 5 tadi, or group 2, right? So you're okay, this is the VI value based on the improvements done by group 2, things like that, you know, or because you only do in your, that's why I was talking about it needs to be a true group work, not just you taking whatever you need and then just doing your part of it. It won't, it will look very weird lah nanti.
Lastly for me kan, you know, I think the other thing is check your OTTV again. Even though the calculation too at the end of the day between you and the first group looks the same, with improvement. Okay, but before the improvement tu kan, I can see that your color section tu nampak macam a bit it's not dark enough. As far as I remember, I think the color is a lot darker. You know, it could be way down in your chart too. Therefore, you know, your TTV too is different, different in terms of calculation comparable to the other one. Okay, but never mind. That's one thing that you could look into lah. Okay.
I'm sorry.
Yeah,
I have a question. Just a quick one. Since for renewable energy, for my group previously we proposed two systems. So actually the solar panels itself can gain 5 GBI points already, which is the max. But we proposed another solution which gains another 2 GBI points. So in the end, for the BEI calculation, should it be just like the solar panels that we chose since it gives more GBI points, or should it be both? I'm confused for that.
In the real world, they will just use the solar panel lah.
Yeah,
It's a waste of money, right? But I think my main concern is with your, because the BEI is on the baseline is so huge, and then your katalah you get 5 points. That means 2% improvement, right? 2% load of the electrical load, the current electrical load. That 2% is huge, tau. So how can you get that 2%? I mean, like, that's my worry.
Yeah, okay. We will check on the BEI lah. Tapi on the baseline. Tapi for our academic purpose, the final BEI should be a sum of everything, is it?
Sum of
of our
everything,
proposal.
Yeah, sum of
Okay.
everything. Sum of
Okay.
everything.
So you have to have two
Thank you.
numbers. Okay, the first number is based on whatever we have now,
Mm-mm.
and then the second one is with improvement. Okay.
Okay.
If it was real pun, the calculation would be the sum of everything. Cuma if it was real, people won't spend so much money lah, because you already achieved it during the using the solar panel. Then you ask the university to install lagi the turbines. Macam mesti pembangunan semua macam apa budak ni kan.
Our ROI will go
I
will
know.
skyrocket so much.
Yeah. Correct.
Okay.
Actually,
Thank
in the
you.
report kan, you have to put in ROI kan, you know.
Yeah, that's why we like takut. Okay. Thank you.
That's where the sensibilities come in, kan, you know, the money. Okay, never mind. We'll move on to the next group. Is it IEQ group?
Yeah. I think with that said, EE is the most important and the biggest portion. So memang susah lah EE ni. Even professionals pun struggle. So maybe kena check balik lah. Okay, move on. Sorry.
IEQ?
Yeah.
Try, yeah, okay. Screen please. Okay, thanks.
Yeah, good afternoon, everyone. So, yeah, group 1 from doing the indoor environment quality, IEQ. So, today we're going to talk about a little bit about the IEQ, which is defined as the environment quality related to the health and well-being of the building occupants. So, it's not only about the building, but IEQ is also about the occupants, the students, the lecturers, the staff in Mercu Alam Bina. So yeah, so the first criteria is let my teammates to present.
Okay, for EQ1 minimum
air quality. Next. The aim is to provide minimum indoor air quality performance in buildings to ensure comfort and well-being of building equipment. So meaning that to allow outdoor air into indoor spaces through natural ventilation. So the existing Mercu Alam Bina already meet the requirement of 5% of floor area with operable top hung windows to allow natural ventilation. I also propose another way that can be done to allow more natural ventilation into the building for retrofit, which can be applied in 5 to 10 years, is to have an open floor plan with louvered folding partition wall to encourage the whole building cross ventilation and to improve the circulation of internal airflow. I also propose a ceiling fan to be installed in the room so that it can reduce the energy consumption and also the cost. For renovation, I propose an advanced design of new buildings, which is ARV system that bring outdoor air into the building. So by having this mechanical system, it helps to transfer the humidity from the outside and remove the still air. Next. For EQ2, tobacco smoke control, wish to provide a smoking zone area. We cannot meet the criteria because smoking is not allowed in educational buildings. Next. For EQ3, CO2 monitoring and control, the existing building doesn't have any of it. Next. The requirement is to install CO2 monitoring and control system, at least one CO2 sensor at main written points on each floor. Next. So I propose 9 CO2 sensor at a level 3 Mercu Alam Bina, and they are not linked to main building ventilation control system, which only act as an indicator to detect CO2 concentration. So when CO2 level exceeds 1000 ppm, there will be a red light signal on the sensor. So what we can do is to open the doors to enclosed spaces to reduce the CO2 level, or open the door to the elevator lobbies. Next. Here is the formula to calculate the gas concentration, and the table below is the example of the ppm reading of CO2 sensor under different temperature and pressure condition. Next.
Okay, next is indoor air pollutant. So it is to minimize impact on occupant health and minimal to use low VOC and formaldehyde content. Next. Okay, so this is just the overall of what I'm going to explain next. Okay, so for the VOC, based on the EQ, they used emulsion paint. So I'm not sure about the if it's low VOC or not, but it doesn't state it. So for retrofit and renovation, what we can do is to repaint using low VOC paint, such as Nippon Odorless. And then as you can see at this diagram here is a level 8. Most of the rooms they used carpets. So it's stated here that the carpet is complete with polyester spun bonded. So it is non-woven fabric, and also it is VOC absorbing material. So I guess it's considered as free green carpet. So for if retrofit and renovation, can use the PVC free carpet, but must meet the testing to comply with the requirements. And others is sealant and adhesive, but it doesn't state it so detailed about the low VOC. So what we can do is for renovation or retrofit, to use a VOC adhesive and sealant. Okay, next is to use the
composite wood, no added urea formaldehyde. So as you can see here is this area is they used a timber floor. So so for what we can do is for renovation is to use a composite wood, and others also for like plywood. Like this area they use for the built-in furniture, they use plywood. So for renovation and retrofit can we're proposing more composite wood. Next. So for more, next is more prevention. It's to prevent microbacteria. Okay, so this mold is usually at the basements, washrooms, and crawl spaces. So in our faculty, that all the toilets are naturally ventilated through windows, but we are proposing like to invest in an effective mechanical exhaust fan system, so it can ensure the moisture is properly suck out. Next is repair, to always to check for the leaks if any, and preventive aircon units regularly, and to discard to discard materials like such as porous materials that is damaged, like carpets, gypsum wall, and drywall. And also they can also for maintenance purpose, we can use equipment such as moisture meter or an infrared camera to detect moisture in building. Okay, so as this is right for the leaking and all is I found that on the roof is all waterproof. So what we propose is during construction and operation to ensure the moisture in building is taken into consideration, such as material to be fully covered, and then make sure to use drying equipment such as the humidifier and blowers, and humidity control of the site. Yeah. Next.
Sorry, 2 minutes left. Thank you.
Okay, so for the EQ6, the objective of this thermal comfort is to recognize that buildings are designed with good thermal comforts and supports the productivity and well-being of the building occupants with the systems controlled by individual occupants. So next, so from our observations, our existing Metro Alam Bina had met the 2 points by using the mechanical ventilators to achieve thermal comforts with the multi-speed types of mountain air conditions, which to supply at least 4 units of aircon in each lecture rooms or studio. And meanwhile, for the corridor space are natural ventilated. Next. So because using the multi-speed types of mounted mounted aircon, so it can be controlled individually by the occupants. So next. So those that had this Metro Alam Bina has achieved the points for this criteria, we still can provide or propose some improvement or enhancement proposal to maintain the indoor thermal comforts by controlling the 3 thermal environments parameter, which is the air temperature, relative humidity, and air velocity. So as mentioned that the existing buildings are controlled by the daylight control. The thermal comfort is controlled by the daylight, which is with the aircon splits and also the VAV system to be provided at the auditorium. So what we can maintain or retrofit for this existing building is we can provide a smart thermostat, which is a device to automatically control the room thermals with the provisions of room temperature and humidity display. It can be provided in each room, which is connected to the wireless network connections to maintain the indoor operative temperature between 24 to 26 degrees Celsius and relative humidity below 65%. So To go further higher cost, it can be provide a smart window blinds or smart window control, which the blind fabrics can be choose with the higher specs, which can reflect the heat or to reduce the heat transmission from outside daylight to inside the door, indoor. So the automatic window control can be block out direct sunlight and opens while dim inside due to the cloudy day. So next, for EQ7, the air change effectiveness, so is to ensure the effective delivery of clean air and to promote a healthy indoor environment. So next. So from our observations, mechanical ventilators with multi-split types of mountain aircon are provided for most of the rooms, including the studios, lecture rooms, and management office using Metro Alam. So, but this will cause short circuitings and temperature islands due to the air movements are constantly slow and less effective air change and thermal discomfort, as showing in the diagrams that, like assuming this is there is the multi-split types of aircons, the outdoor air will slowly just start from the center and slowly go to the other round, which is they needs more times durations to maintain or to reach the thermal comfort level. Next, so what we can propose or to enhance this proposal is providing the personalized ventilations, which to enhance the thermal comforts or the quality of ventilations, at the same time to minimize or maintain the clear heights of the room. So this personalized ventilation PV aims is to supply clean and cool air direct to the breathing zone of the occupants, which can be divided into two types of PV, which is ceiling mounted personalized ventilation and spot types personalized ventilation units. Both of these types have their pros and cons, which, for example, the ceiling mounted PV give the benefits of supply air terminal device installed on the ceiling without any ducting required for supply of outdoor air into each workspace that improve the indoor aesthetic and provide higher levels of flexibility in the furniture layout. So while the spot types will be more concerns of the furniture layout, which need the constant furniture layout at the workspace. So, but both of these PV have concludes that may reduce the energy consumption substantially up to 51% compared to missing ventilator alone with the control strategy applied, which is reducing the airflow rate and increasing the maximum allowed room temperature and supply air only the occupants in the decks. Okay, that's all. Next.
Yeah, I'll continue. I'll go through quite quickly. For the later parts, we have, I'll talk about 4 daylightings and lightings issues. For EQ8, it's daylighting, basically to provide good levels of daylighting. Next. This is just a method of assessment where we use the rule of thumb, mentioned also by architect Michael Cheng, taking the head height of the window times 1.5 to get the depth. So by using this one, next, we can see that the calculation, this is one of the typical plan at level 5. So this is the calculation we got. Basically, it achieved 41.39% of the NLA, which means that we get 1 marks from this category, but the maximum point is 2 marks. Continue with the other methods we use. We have to go to the next page. This is another method that we use, which is not so convincing because this is basically the data we obtained when the team visited to UM. So basically the illuminance and the daylight factor is far away from the requirement. So the range, it should be between 1 to 3.5, but it happens to have everything below 1. So I think this is not, this data is not so conclusive, and we have to carry out a second method, a second assessment if possible. And next, so I'll go through this really quickly because the second method basically is to have 3 lux meter, place 2 on the roof and 1 on the table, and then we measure everything and divide accordingly to get the calculations next. A few solutions to actually for us to achieve the 2 points. The first one is retrofit using this daylight redirecting film, where it redirect the daylight and it penetrates deeper into the building. Next. The second includes, this is just an image to show how the redirecting film works with and without the blinds, and when the sun shines out. It's very clear that it actually gives a better light penetration into the building itself. Next. The second solution is to renovate, where we have a glass in between the studio when you enter from the studio into the corridor, because the corridor is quite dark based on the photo taken. So this is one of the solutions which would use a higher cost. And next. Other higher cost renovation where the budget is allowed it will be horizontal light pipes, and also another one is the automated reflective slats, which is already mentioned just now by the second group when they present. It's a prismatic panel together with the reflective slats. So that's also for better daylight penetration. Next. So this is just a diagram to show how the prismatic panel and the reflective slat can be integrated together for better daylight penetration. Next. For glare control, next. It's quite simple that we just have to provide the roller blind into the studio and for all the rooms, because I understand, in this slide, actually, basically we want to show the contrast and how glare actually occurs. When the contrast is very big, you can see that from the first photo, this is where glare occurs, but when the contrast is very small, the third photo shows that the glare is not so disturbing when we have the roller blinds. Yeah, if we go to the next page, you can see that this is the photo taken in UM. So some are already provided with roller blind and some are not. We just have to provide the roller blind in order to get the 1 point in this category. Yeah, next. Electric lighting level, next. This has maximum 1 point, and right now, based on the data we obtained, it's below what is required in MS 1525. So existing is 0 point, but we suggest a few solutions next. So yeah, these are just some data this is just some diagram showing the data we have collected, and it's below MS 1525. Yeah, next. Yeah, next. So the solution 1, which is pretty straightforward, just increase the power or increase the number of lighting. But solution 2, it needs a higher cost because it's a digital lighting control, where it was also mentioned by another group already. It's an automation system. Next. So in the report, we will further talk about how the digital lighting control should actually focus on the daylight link lighting control, so that it depends on the outdoor daylight and it adjusts accordingly. Yeah, next. High frequency balance. Basically, we also achieve this point because UM is already using all the LED lightings in everywhere. Yeah, next.
So since we are running out of time, so I will make this really quick. So for the next one is the external views, which is to reduce eye strain. So for this one, actually, Masjid Alam Bina actually achieved this one, which providing the unobstructed view for the occupants. So we have assessed the building through the photos by my teammates that went to the building itself. So yeah, but to further discuss this, we'll discuss this in the report. So how to improve if we have costs that can involve the staff and students and lecturers, so that they can have a better learning environment and teaching environment. So for the next one is the internal noise level. For this criteria, actually, because now there's no one in this building, so from the other groups that assess, they have the equipment, they are able to assess that and found out that the Masjid Alam Bina actually achieved this criteria. So, but since the data is not that accurate, so we propose further information, further methods to improve the noise comfort, the acoustic comfort, so that the occupants can have a better experience in this building. So this includes the sound reduction, sound masking, and sound cancellation. So basically sound masking is about when a place is too quiet, like library or office, it can increase the privacy and also improve the comfortable level of speaking in a very quiet area. So yeah. Next is the IEQ before and after occupancy, which is to verify by having the building flush out in the building. Yeah. So for this one, we have a very rough calculation for it, but we are not sure about this one. So actually, we would like to ask questions about this one for Dr. Azam. So yeah. And next one is the comfort survey, which is also to provide assessment of the comfort of the building occupants after the retrofit proposal. So this also has been proposed as a survey. Yeah, so that's all for our presentation. Yeah, thank you.
Dr. Azam, should I start?
Yeah, go ahead.
Yeah, I think first and foremost, you need to have, like, when you start the presentation, it's best to have like a summary of your point lah. Like for example, from EQ1 to EQ13, right? What EQ1, how much you score, EQ2, how much you score, then you go one by one. Because on some of the chapters, I don't even see the point. Where's the point? Where's the point, right? And what is the important part about that point? Kan, macam for example, macam EQ13, you need to have say, you know, the 40 decibels for offices, 45 decibels, right? For the closed offices, for the acoustics, kan, you were talking about. I mean, you are suggesting macam, you know, extra things. Wow, how does that help? Because how do you assume that you don't have the data, but your assumption is noisy? How do you assume that? Yeah, what is your assumption that you need all those muffler?
Yeah, but because during this situation, we are not able to assess the real situation which the building is occupied with occupants. So we just can assume that it will be this situation. So yeah, that's
yeah. But what are you doing there? The things that you're adding. The slide number 30. The next slide. No, the top one.
Oh, this one. It's actually for the service ducts, for the pipes that run through the ceiling from the service room to across the corridors.
So it's got nothing to do with occupancy, right?
Because from the corridors level, that will be affecting the occupancy as well. So we just assume that this can be done if it's noisy. So yeah.
No, my point is, all this GBI, not just for you lah, for all the groups, all these subcategories, all have a reason, right? Say for example, your EQ13 is to ensure that you can be very comfortable that you're working in a non-noisy space, correct?
Yes.
So when you are in your own experience in Mercu Alam Bina, you have been there, right? You have worked there.
We have the team of us have never been there before. Have never been there work there before.
The whole team have never been to Mercu.
Working.
They came from different universities.
Not from
okay.
We have not worked there before. Yeah.
Okay, fine. But because my thinking is, kalau your assumption should be based on a normal, because when they did the stool, this 45 dB, 40 dB number came from normal offices that you can work in, like general office. that is the acceptable background noise level lah, 45 decibels, 40 decibels, so you can still work in. So I mean, like, when you do a report, you have to mention that whether you want to achieve your whatever you want to do is affecting the target or not affecting the target. And I think that's important for all the sub criteria lah. Macam, for example, another example, say for example glare. What does the criteria want, and where are you achieving it? I don't see that. I see a lot of explanation, which is good. You're researching, but in terms of actually achieving the point, perhaps because I worry that a lot of you don't understand why is there a point there, or the actual reason behind it lah. Because at the end of the day, green building index or any other tool is not just about ticking the points, right? It's about understanding why it's done that way, so that you can create a better building lah, as architects or as engineers or as designers. So so I think because the way that you have written your report is like just a general explanation, perhaps you need to put in, like, first, what is the baseline, what are you doing to improve, and the points that you get for each, and what is the main thing that you're looking at, you know?
Yes, because based on the baseline from the GBI, like for the internal noise level, for instance, it actually achieved. So we have like no further information can be done into this building, but we cannot say that this building is already perfect.
The simplest
So
thing
we're
you can
just
do
trying
now.
we're just trying to like find some methods to like improve. So like just a proposal to improve.
Beyond
Because
the minimum lah.
Yeah, in my view, can, you know, if you already achieved it, then, you know, not necessarily you have to improve it, kan, you know. Tapi itulah, right now ni, in terms of getting the baseline noise data, kan, you know, the only place that you can get right now during this quiet period, kan, you know, it's only at level 8. Because, you know, the rest of the building is really quiet, kan, you know, it's unoccupied at all. But, you know, there's definitely quite an amount of noise juga lah, kan, okay. Perhaps, kan, you know, when you come back later on after this exercise, you can do another measurement and find out exactly for yourself. To me, kan, right now for this exercise, you've done it already, and then it says that you've achieved the mark, then that's it. And then there's nothing much you can improve further anyways, kan, you know. In terms of ducting, kan, as far as I know lah, kan, that building doesn't have a lot of ducts tau, you know, because, you know, all the water is kept to one end, and then, you know, in terms of aircon pula, it's only just a series of copper pipes here and there, and there's no noise at all. We don't have a lot of noise coming from the main stuff, okay, even the lifts are quite quiet. So you know, most of the noise will come from students definitely, kan. Jadi perhaps the improvement can be done in terms of the insulation and the noise insulation and the capability of the partitions.
When you do this this exercise, do you refer to the design reference guide requirements?
Yeah, the GBI, the Green Building Index, right?
The reference guide, because the reference guide is the actual things that you need to submit, right?
Yes.
Because some of you, I see the things that they need to submit. Some of you don't have the things that they require to submit. So that's where the mismatch is lah.
You're gonna have to consolidate, you know, make sure everybody complies lah, kan, you know, with the way that it's supposed to be done.
That's why I think the summary of points is very important.
Yeah.
And
Alright.
do you have a summary, or we missed it, or somehow there's like a total of?
Actually, we didn't include this in this slide because we haven't like really concluded the marks yet, so we didn't include it in this slide. But we have that already in the report, so we're like calculating, in the midst of calculating right now.
Again, please talk to one another lah. Tazam, saya takut I'm afraid that they don't talk to one another because what they, one thing might be not in line with the other. Say for example, one person is talking about reducing glare with one strategy that actually is against the other guys
Contradict the other one, yeah.
providing more daylight, you know, that kind of thing, because
Yep.
you're not talking to one another. So macam pelik.
You see, you have to have a clear kind of vision, you know, what you want to have, you know. Is it the case that you want to increase the amount of daylighting, and then, you know, you're going to have to sort of look into how you can improve the temperature after that. Or perhaps, you know, you forget about daylighting at all, can, you know, concentrate on artificial lighting, take a hit on bugs over there. And then, but at least you should be able to cover in terms of thermal comfort, kan? So there have to be a balance somewhere. You know, you can't have, you know, not really you can't have, but having too much more daylighting plus apa nama, it will definitely bring in a lot of heat as well. Otherwise, you might have to look into the specification of the glass and, you know, change something like that, kan? You know, or more information so that you don't get heat coming in. So yeah, tak apa. Now look back at the proposal you have done. Okay, make sure that everything is in line. Okay, means say what is the ultimate goal that you want to have. Okay, for IEQ, for environmental quality, right? So and then target that. Okay, rather than, you know, targeting so many things at the same time and they're not in line. All right.
All right.
Okay. Okay, we move on to the next group.
All right, thank you, Samantha.
All right. Thank you.
Next IEQ. Next EQ.
Hi, good afternoon, everyone. I'm Sinchin here. We are from Group 3. We are doing the indoor environment quality. Our group members are Leba, Cheryl, Marine, Minnie, and Mei Chen. And then now I will explain the criteria EQ1 until EQ4, which is about the air quality. For the EQ1 and EQ2, because the existing building, they have met the minimum IAQ performance, so we didn't have any proposed for improvement about this. And for the EQ2, which is the environmental tobacco smoke control, because the Masjid Alam Bina building is the education institution, so it's prohibit for the smoking. So this one we also didn't have any proposed for improve. For EQ3 and EQ4, I will explain later. And then this one is for EQ1. At the left hand side, this one is the acceptable range we take from the Department of Occupation, Safety and Health. And this one is, and right hand side is the data we collect at 19 December around afternoon. Time is 11 until 12 p.m. And we take the reading at the corridor level 9 and the air velocity. And this data is actually quite accurate because based on the environment there, but almost have same with the acceptable range. So have meet the minimum requirement. And then for the EQ2, which is the building is prohibit smoking, so this one already hit the score. And for EQ3, because the whole building is lack of the carbon dioxide monitoring and control, so we propose to have the demand control ventilation, which is carbon dioxide, CO2 at the high density area, which is the studio area and the Bilik Kuliah area. And this one will install the CO2 sensor we install at the studio area, and then when the population in the studio increase, then the concentration of CO2 also increase. So we send signal to the HVC with the DVC control application. So the fan will speed up and extract the CO2 to outside, and the fan speed will reduce when the CO2 level is dropped. And for the next is the EQ4, indoor air pollutant. From the BQ, Metro Alam Bina BQ, we found that the internal wall paint does not state that they're using the low VOC paint. And also the adhesive for the tiles, they also do not use the low VOC. So we propose to have the barrier coating, low VOC barrier coating on the high VOC surface, so can control the contaminant release from the surface. And the next one is the material selection, which the interior, if you want to repaint, we can select the low VOC painting. And the third one is the installation sequence, which the material like composite wood product can install first. After that, the second install is the carpet and fabric wall, which can absorb the VOC. Next, I will pass to my groupmate Mini.
So next, I will talk about EQ5, which is the mold preventions. And based on the site visit and the observation, we found that Merchant Alam Bina actually have potentials, have the problem of diffusion of moist through the wall and the roof. And also the indoor moisture sources may be through the improper storage of the cleaning product and no proper entrance statements. So the next one is here we have found out the three issue, which is after visits we found is lack of appropriate storage for the cleaning products, and there's no proper entrance statement. And the next one is from the drawing itself, we found that most of the wall is using the flash drive partition as yeah. So the next one, yeah. So for the we come up some proposal to hit the EQ5. One of the proposal is provide an effective trap-off system at the entrance, which is maybe we can have a well-designed layout walkway using the textural pavement material before we enter to the main entrance of Merchant Alam, which is the nearby the in front of the lift lobby there. Because now based on our observation is open lobby. And to have a trap-off system actually is to keep the building entrance way clean, and maybe we can integrate some landscape materials. Yeah. Next. And the second one is associated with the cleaning and maintenance, which is maybe we can use the provide a appropriate raw storage for the cleaning product, because after a visit we found that actually there's a potential a space that we can change the space, which is the entrance to the female toilet there. We can change it to for janitor room, or yeah. And the figure below is actually our proposal, and where we can do is we can make it simple in a simple way, which is we can change the entrance for to the female toilets, and so the spaces can be used it as a cleaning and storage. And the next one is the moisture management in the wall assembly. Because based on the drawings, we found for the lecturer room, actually for now they are using the flash drive partition with the rockwood insulation. So it might be has a potential food source under the moisture heavy condition. So to improve this one, maybe we can use the gypsum board product that can able to extract the VOC from the A and to neutralize them within the wall, and use we also propose to apply the membrane vapor retardants on the existing gypsum board to provide a continuous air barrier to to prevent the mold, to prevent the air moisture. Next slide.
So for my part, I will present the EQ6 thermal comfort control of system and EQ7 air change effectiveness. So the one of the problem is that we observe the studio, like for example, the sharing space is lack of individual comfort control. So my proposal is to implement the individual comfort control, as in using the underfloor air distribution system. So this is how the UADW underfloor air distribution work is just raise up another layer of the floor plate, then implement the air supply, then with the central air handling. So actually we have hit the one point. The existing one have provided the HVAC system with a control with a key control mounting on the wall. We hit one point, but to enhance it, then we propose the underfloor air distribution to enhance the thermal comfort, to control enhance the thermal comfort contributely system to fulfill the individual comfort in a shared space. So the one of the supplier that we, next. Okay. Next. I didn't say the next, sorry. Okay. Yeah, sorry, this is just now I explained like how the thing works. Yeah, so next. So actually we have already hit one of the point of the, because they are already using HVAC system. So to achieve another point, we propose the UFAD system. So one of the supplier that we research is the SUM system solution. Next. So for the air change effectiveness, actually already achieved the point, because along the corridor already have provide the supply ventilation system, and also in the interior space they already have the openable window. Yeah, next.
Hi, I'm Lebat. I'm going to talk about EQ8 until EQ13. This is the summary of our observation, the GBI score, and how do we improve on the criterion that we didn't meet. So yeah, the daylighting, because we're using two calculations method, I'll be explaining it later where we have a bit of inconclusive data. I will explain on that later. And the daylight control, apparently based on a lot of, like I've heard the seniors talking about how sometimes during presentation, they have like glare problem that it's so bad they're using umbrellas while presenting their work in the rooms. And for that, the building hit 0. And then for the electric lighting levels, some classrooms and hallways appear to be like very dark without the artificial light. Even with artificial lighting, actually, I'll provide pictures later to prove that. And for the EQ11, we hit the mark because the whole building uses LED. And for external views, we also hit the mark because of the huge windows. Next. For the EQ13, it's a bit of inconclusive as well. So I think it's not right for me to put one later. I'd like to discuss that with you later, Dr. Azam. Next. So for daylighting, the first formula that I used was to use the BRE method, the experimental formula that a lot of UK institution is using. So for this, using this method, we're taking the sun angle into account. But and from this calculation, we hit the more than 2%, I think, of daylighting factors, and that means that we hit the two target, the two maximum target of the criterion. Next. But when we went to site, it was quite overcast and it's a bit mendong lah, the weather. So the reading was far off actually. Yeah, the reading was far off. So the factors behind the difference of the large deviation might be because the BRE method does not take into account the presence of any solar shading, because we have the 1.5 meter overhang, right? That and the limitation of data collected, we only have one set of data. So because I believe that we need to go there to get multiple set of readings. And I think we need to get more analysis after the post-occupancy, the post-occupancy studies. Next. Next is the observation on site based on the photos alone. So the hallway is, while the classroom is well lit, the hallway is actually quite dark. So we have a low cost and high cost strategy in how to tackle this problem. The low cost is to actually just fit small, fit windows along the corridor, to add more windows so the light somehow can go through. But I think that wouldn't work because the plan is too deep. The high cost is actually to replace all the brick walls along the hallway and replace it with frosted glass. So the privacy can be maintained, but you can still let the sunlight in. Next. So this one is the prototype of anidolic daylighting system. But because it's prototype, it's not mass produced. The simulation is not quite there yet, unless, well, there's one simulation that's done by a Singaporean institute, but I think I'm not sure how to access to that, so I can't really study how much of a percentage does extra light can be brought into the hallway. Next, it's a worthy solution to check out lah. So the next one is daylight glare control. It does not fulfill EQ9 as shown by this sunlight studies. The room receives a lot of glare, partly due to the big windows actually, and the solar shading is not regular. I mean, it's not regular, so it does not really mitigate glare throughout the facade. So we're thinking of installing electrochromic glazing, which is quite high cost. Yeah, I know it's very high cost, where you have where we can integrate this on the hallway glass as well. Of course, it's expensive, and we need to take into account that we might need to have like a BMS center at somewhere in the building lah. And the glass zoning also. Well, the lower cost is to actually just have glazing, replacing all the brick walls. The higher cost would be actually replacing the brick walls with electronic glazing. So the lowest cost is actually to have light pane. So the light can bounce freely inside the room, because right now most of the classroom is a bit like dark blue or dark green, I can't remember. And there's automatic sensor because of the electrochromic. Next is the summary of how we tackle the EQ8 and EQ9 criteria. So the first one is installing a deeper louver system with slanted louvers, because what we have right now in the existing building, it does not actually affect much, because the louvers are actually quite separated from each other. It's quite far from each other. And then the second one is installing electrochromic window to significantly reduce glare, but this one will probably need BMS room. And then the deeper louver system is the side effect, the extra cost is to have the labor costs in demolishing the overhang and remove the whole existing louver system actually. And the installation of anidolic lighting system, the extra cost will be, if we install above the suspended ceiling, the obstructing beams need to be demolished or cored. So the CNS consultation might be needed. So that is extra cost. So the fourth one is to replace the entire brick wall at the hallway with frosted glass or electronic glazing. And the extra cost will be demolishing the entire brick wall. Next. This is the lower cost strategy, is to have roller blind to minimize glare and repaint the walls with non-reflective coating, or to repaint the overhangs with non-reflective coating to minimize glare. Because we surmise that the glare might be contributed by the large overhang over here when the sunlight bounce on the white surface over here, it will bounce into the room. That is just the assumption, because we didn't go to the site during sunny day. We only went there on overcast. Next. Yeah, EQ11 and EQ12 are fulfilled based on existing condition. EQ10 is electrical light. EQ11 is the high frequency ballast. Because we're using LED, so that the criterion is nil, or we fulfill that. External views also, we fulfill that as well due to the large windows. And the EQ10, as I said just now, some of the areas are quite dark, so it might be useful to actually have a digital addressable lighting interface that actually monitors and manage the lighting system throughout the building. So if so there will be sensors planted outside the building to sense the sunlight penetrating into the building. So the system will adjust accordingly to give the optimum light. Next.
Sorry to interrupt, but we are kind of running out of time.
Whoops. Okay, right. So based on the BQ for our EQ13, there are some treatments for walls, for the ceiling, and for the floor. And then we only managed to get into one room, get into one room, which is at the level 3 actually. And then we have people talking, and this is the reading that we have. It's between 39 to 42. So within in the criteria, we found out that this is acceptable for closed office spaces. So we hit 1 mark here. Next.
Alright, so basically, which is the last one, EQ 14 and 15. So over here is the IIQ before and during occupancy. So we get an option over here, and it is not to provide not less than 10 air changes per hour for at least 30 minutes. So basically, we have the area and also the height of the studio, and we get the SEH over here, which is 671 and 67 CFM. And then we got from that, we got volume of air required, which is 201,501 CUFT. Next. And this is the table of calculation of before and after. Next. And also the EQ15 post occupancy comfort survey over here. Okay, that's all from our group. Thank you.
Wow.
Thanks, Jason.
Yeah, I think this group, I think is a bit more systematic. I think you notice in the front there's the summary that we were talking about. Me and Dr. Azhar were talking about. So it's very clear what the baseline is and what you are trying to and some of it, like for example the acoustics. I think the other group, you can listen to this group how they did the acoustics, right? There's some calculation, some assumption. Even if you don't go there, there's an assumption for office and whatnot. So I think can learn something lah. But there's a few things that I think may need a bit more improvement. One is the mold prevention. I think you put your suggestion is to sort of like cordon off the entrance on the ground floor, right? Yeah, so I think that would not help mold. In fact, it will be even more detrimental to the accumulation of mold, because once you glass it up and you don't open up, there's not much ventilation, and then your relative humidity will actually rise, because I think the idea of this EQ5 is to get a very low relative humidity, right? So that mold cannot grow. But if you imagine like you're breathing into a glass box, there's going to be more humidity in there rather than it's an open air thing, right? So having this glass box of a red line, it's not such a good idea. Maybe alternatively, you just leave it the way it is. I mean, like there's no mold anyway, and make sure there's no leaking. And I think the toilets area, I agree with you that you need to improve that. Openings, maybe the simple way to do it is to have extractors and more ventilation, and keep away all the wet stuff and whatnot. But okay, maybe I just detract and talk to everybody that GBI is a performance tool, right? So there's many ways to skin a cat. So there is the complicated, super complicated way, and there's the easy way. And always you should train to be the easy way. You look at example, you don't have to go far. You look at examples, say for example, to platinum buildings like Menara KKR versus PAM building, for example. Both are platinum rated. That means when you look at all your criteria in the GBI tool, these are the highest criteria, but one is super creating a lot of problem and trying to solve it in very inventive ways. And like the PAM building, it just takes the cheapest, easiest solution that you can do. So I think your approach somehow needs to be like that lah. And this is what I'm referring to. Like for example, just now there was a mention of raised floor for the air control system. I think that one is a bit difficult because what you're talking about is a plenum. You guys know what a plenum is? That means it's the whole floor becomes like a van lah. And the problem is what happens to the corridor, right? Does the corridor there's a change of level in the corridor as well?
And the lift lobby.
But there's so many things that's going to be like a problem lah. So this kind of thing, what was it? In a way, what is the best way to do this air change effectiveness, right? To ensure rather than do the more difficult way, why don't you do the more simple way, like hybrid ventilation, for example, combining natural ventilation and aircon, modifying some of the basic HVAC system. Because I think generally our windows are quite large already, and perhaps even suggesting more operable windows. Because if you notice on the facade, the number of operable panes, very, very few, right? As opposed to the whole glass area. So I think simple things like that should be also considered lah. Just now I did a note here, lighting. Can you just go to the lighting slide using BRF? Yeah, okay, this daylighting thing, I think you mentioned that the results is way beyond, it doesn't correlate, because you shouldn't be using the BRE method, because you should be using what Dr. Azam gave you, the MS 1525, 2007, because BREEAM, which was created in the United Kingdom, is a totally different environmental sort of like considerations there, as opposed to what we are here needing in the tropics lah. That's why we have different green building tools in each country, because each country got different environment. So
they've got different sky condition as well.
Yeah, so you can't be using the BRE for and I think it's very clear already in the MS 1525. So just use the MS 1525 lah. Yeah, and I think your reading would correlate better with the addition of extra shading and all that, and what you need to do lah. Okay, so I think those are my comments on your report.
Just correct those things, okay? I think Akina has pointed out all the things that I wanted to say as well. Satu yang the daylighting just now, and then secondly, especially the raised floor. I think that one is a no-go, okay? Because you'll be creating other problems as well. And not just about the leveling issue, but at the same time later on you have You've got infestations in there. You know, the rats which are already there in the studios, they really love it. And then
Rat house.
yeah, there's a lot of maintenance issues that kind, with regard to raised floor. And then raised floor is a very old technology, and people try to get rid of it. Some or other is still sticking along. So, and then same time we don't have a lot of headroom anyways, kan. So I think that's not the best thing to do lah. Because spending a lot of money for something that we don't really require lah, kan. Okay. And then for the mold prevention thing, yeah, it's all about ventilation. If the rooms are well ventilated, you have operable windows, which we do have, but normally they are closed. Okay, so if there's a schedule, of opening up the windows at certain times of the day, that'd be great. And then we only have certain wet areas, toilets, and also the kitchen downstairs. Okay, so in the toilets too, yeah, we don't have a lot of openings. And then the extractor too, not really working well, like kind of thing. So perhaps better extractors. And then in the kitchen downstairs as well, better extractors as well. So other than that, you don't need amazing stuff, to deal with those things. Okay. Last but not least, your corridor, kan. The corridor tu, itulah. That's what I was saying earlier on. Strategy is very important. Sometimes you have to sacrifice things, kan. Okay. So if the corridors are dark, so what? Go and handle artificial lighting, right? Because the studios are more important. If you have to put glass partitions all along the corridor, no problem, can be done. But it's just extra cost for small gains. Okay. Whereas, you could easily just use LED lighting like what we have right now and not use so much more energy anyways, kan? So you're gonna have to sort of balance those two things out lah, kan? Okay, so yeah, all right. Just correct all the small things and then get your report done. Okay. Can we move on to the next? Yeah.
Sorry, can I ask? We want to ask if we need to do ROI for.
Oh yeah, you have to for the report. So sekarang ni, right now, kan, based on the comments, just take out some of the proposals you have done which are not really required. So the ROI should be a lot easier, kan, because it'll be a lot cheaper. Okay.
Okay. Thank you.
Alright. I think the most expensive one is definitely the raised floor thing. Okay.
Maybe I just add something because the two examples I mentioned just now, the PAM building and the KKR building. The KKR building is super expensive. It has triple glazed glass, just because it wants to keep its shape and all those fancy triangular windows and whatnot. But the PAM building is built at a cost because PAM got no money, right? So I mean, that's the approach you should look at lah, and when you want to look at your ROI.
Well, what makes PAM building more special is that the orientation is bad, and then it's got a lot of shading from the building behind it and also at the front. There's no daylighting. There's no easy access to daylighting. But somehow or other they managed to do it, kan? So yeah, strategy. The KKR building too is showcasing, kan, to be like a trophy kind of thing, like in the middle of the city, kan, they've got some image thing to look after as well. So yeah, for us sitting on the hill as well, we do have something to look after. But nevertheless, kan, you look into you can come up with strategy, kan. That strategy too is actually what you want to achieve. The aim that can be at the front of your report, kan. Your aim for EQ, right? Okay, let's move on. We've got 4 more groups to go.
Oh sorry banyak sangat komen.
Thank you Aditya, Sally, thank you Dr. Azam.
Alright, who's next? Water ke material ke sustainable site? Alright, okay. Betul 4 more groups
Yeah, 4 more.
Okay, go on.
So very good afternoon, everyone. So we are from Group 6 and we are going to present about sustainable site planning and management. And so here's the summary of our assessment criteria, which involves facility management, transportation, and also reduce heat island effect, which will be covered later on. So first of all is SM1, which is the GBI rated and construction. So according to the architect design concept, the architect actually intended to design mature alam bina which can be used by students as a reference. So we actually pick up some relevant info that could contribute to GBI. So first is the precast building system, which is having consistent dimensions of building element as shown and as in the diagram, and also sawn formwork, steel formwork, and timber formwork. So as you can see in the diagram below, offices are actually arranged parallel with the windows to reduce energy consumption of the lighting. We also have rainwater harvesting system, sun shading lattices also have been introduced outside the windows to reduce sun energy consumption of the air conditioning as well. So the building actually designed to allow ventilation to corridors, lift lobbies, staircases, toilets, and also parking. However, the architect stated in their website actually the workmanship of this building is 60% satisfactory due to the unskilled workers and not taking care of the finished products by the contractors. So the green building certification, very unfortunately, currently we does not receive any GBI certification yet. So we loses 1 point for this criterion. So to achieve this criterion, FBE should obtain the certifications and maintain those certifications within 12 months. Here are some of the GBI assessment process. The first stage is application and registration. Another
You can skip this one.
okay. So I'll pass it to Heather for SM2.
Yeah, so for this SM2, which is the exterior facade management, for this part will be contain 1 point. So for here, we will look into the building roof and also the exterior facade of the building. So for this criteria, the goals to achieve is to encourage an environmental sensitive exterior management practice that provide a clean, well-maintained and safe building exterior while supporting the higher performance of the building operations. So for the assessment description is to employ an environmental sensitive low impact building exterior to the environment and have a best management practice where significantly reduce the harmful chemical use in this management plan. And the third one is the using the non-polluting methods and chemicals for the cleaning agents of the building exteriors, which including three things want to look in, which is the maintenance equipment, chemicals, paint, and sealant. So for the quality assurance and the control process, proposing that the management team of the building shall conduct a building exteriors and roof area inspection at least once a week to evaluate the continued efficiency of this plan. Also, quarterly basis meeting to review and discuss the building's most performance based on the assessment metric, and also shall be record in the GBI compliance logbook. And then the third is the quarterly basis meeting shall also discuss about the viability of the current performance metrics as an effective measurement of the plan's successful implementation. So for the implementation proposal, the first part we look in is the maintenance equipment. I'm proposing using to install the socket and David arm system. This system can providing paramount access to complete regular maintenance check or cleaning duties around the facade of a building. So this system is suitable to install at the roof level of the building. You can see I'm highlighted with the red boxes, and allow the cleaning specialist to assess the exterior facade of to clean level 9 and 10 for cleaning and maintenance. So the elevation illustrate the places that the portion of the elevation that can be accessed with this system. Next. So and then the other point is that utilize the exterior RC ledge as the cleaning platform. So this RC ledge is located at the facade from level 1 to level 8, And then this RC also partially have the louvers cover, which also adding point for the safety consideration for the cleaner. So the cleaning specialist can just use a simple cleaning tools such as a scrubber and window wiper. Yeah, and then the second point to look at is the cleaning chemicals. Since the building has various facade materials, we need to take considerates that there is three main types of materials, which is the metal deck roofing, stucco wall, and also the glass window. So the cleaning agent that selected shall be least harmful chemicals, and then least energy waste, and then also prevent chemical runoff. So it also can be using the deionized water with a scrubber to clean the glass window once per month. And then the roof of the building shall also clean and inspect once for every 6 months. The roof system that using is have a 30 years plus of the life cycle materials which contain recycled materials, so it can achieve a greater life cycles. And the last part is the paints and the sealant. Selection of these paints and sealants used for maintenance. The product selection shall be certified as a green product with low volate organic compounds, ammonia-free and non-toxic, which does not contain lead, mercury, and heavy metals. Which all these substances will be impactful to the environment. So need to prevent using those kinds of the products during the maintenance. Yeah. Next.
Okay, I will be explaining the integrated pest management, erosion control, and landscape management. The first one is introducing the adoption of organic pesticide and fungicide, which is neem oil. It is actually recognized by the World Health Organization and United Nations Environment Program report. So it's actually biodegradable, and it helps to detase the plants so that the insect wouldn't eat it, and then it disrupts the system of the growth of the insects. And then it's, other than that, it's also bactericidal, nematicidal, and fungicidal. It sterilizes adults, insect, and pests, and it also helps to as an anti-inflammatory for the plants. And then the next one is for the erosion control. The first image is to show the coverage areas under the study scope. So there's a few steps. The first step is to identify the symptom of the soil erosion, which in the diagram is the symptoms.
Sorry,
and then,
2 minutes left. Thank you.
Okay. And then the erosion control method, the first one is having a contour farming. And then another one is hedge planting along the contour. And then the third one is the recommended vegetation by the Professor Norma Nisa. Yeah, this is the few plants that recommended. Next. And then this one is for the landscape management, the use of organic fertilizer, suggesting on the example of one of the organic fertilizer, which is cocoa peat, which also known as coil fiber clean, produced from the coconut. It's biodegradable and a multi-purpose soil conditioner and growing medium. It also helps to lock the water resources and decrease the use of chemical nutrients. And then it's actually a natural and renewable resources produced from coconut husk. And then for the second one is suggesting on the rain harvesting system to reduce the water usage for irrigation. Yeah, reuse of water. And then the third one is the green wastewater design, which can be part of the green infrastructure initiative. This one actually it can be a recreational amenity and provide wastewater management for our faculty. It's actually a living machine with a concept of treating wastewater while utilizing biological process of the ecological system. Okay, that's all from me.
Sorry, Raina, just now 2 minutes left is just for SM3 or up to SM7?
Sorry, was that? Sorry.
There are 2 minutes left.
Overall.
Yeah, overall, right? So
Yeah.
you're just halfway through. So can you please speed up a bit? Yeah.
Okay, I'll quickly present about this. So SM4 is about green vehicle priority. For now, we do not have any priority parkings. So in order to achieve this 1 point, we actually propose to have this green vehicle priority parking lot in the faculty. So next, also propose on the carpool parking lot, which also proposed to be on the same level as the low fuel car. Yeah. So actually, we also promoted to have this bicycle bank, so we can actually encourage more students to bike instead of using vehicles to go to the faculty. So another proposal is that we wanted to achieve in promoting walkability in our university. So we actually tried to introduce this motion sensor which can generate energy while they walk through up to FAB. And the proposed lane is connecting the engineering faculty to our FAB and also to the medic fac, which actually links the bus stop area inside the university.
Next, I will talk about the greenery and roofs. So first, we are looking at the hardscape and the greenery applications. So first off, we start by identifying and observing the pavements on the Mercu Alam Bina site. And 70% of the site is actually made out of pre-mixed pavements, and which has a low SRI value of 0 to 6. And other pavements such as Grasscrete granite concrete stem, which actually has good SRI value. But then according to the third category of the GBI, the minimum, thank you. I will go through this very fast. And the minimum requirement for the solar reflectance index for the pavements is 29. Okay, next. So our first proposal is actually the open grid pavement systems. It is actually a standard concrete blocks which helps to eliminate the heat buildup in the pavement and roads. So this will allow the surface to remain cooler under the hot sun. And this open grid pavement is also to replace the normal pre-mixed road. Okay, next. So the other proposal is by shading the pavements. So one of our proposal is to introduce this photovoltaic canopies. It can actually work well with the Grasscrete because it allows partial solar to pass through, and then it will also absorb most of the solar radiation and reflect the remaining solar radiation. Yeah, that's all from me.
Next, I will talk about the roof application. There are a total of 2 roof application solutions to reduce the heat island effect. One of them is installing cool or vegetated green roof, which is cool roofs, and another one will be double roof. So the roof of our Alam Bina building is a combination of a white painted aluminum zinc roof with 10-degree force and concrete flat roof. The concrete flat roof is located at the level 9. And the white aluminum zinc plate has a solar reflectance index SRI value of 56, which obey the SRI requirement of cool roof to be more than 29 for a steep sloped roof. Okay, to further reduce the heat gain of the roof, part of the standard aluminum zinc roof can be maintained, and at the same time, we got to implement vegetated roof on the existing building next. So the second one will be the addition of vegetated green roof. The diagram shows the precision to proposed position to install a green roof. So vegetated rooftop at RC flat roof area will help to reduce the heat island effect. There is an existing herbs garden on the RC flat roof of level 9. So the vegetated rooftop will work better for the existing flat roof of a building since the size and scope of the area of plants is adjustable based on the condition of the existing condition of the roof. So another proposed solution will be modular green roof. The picture shows one of the system, which is the green roof tray system. This is very adjustable and easy to assembly and maintain. Next. Okay. Another solution will be double roof. There is an existing double roof, so we gain 1 point for this. The existing faculty of our built environment building was designed with a double roof, which could help to reduce the heat island effect. And then we can propose new double roof also on the auditorium area. Since the auditorium area do not have a double roof, we only have the double roof for the 10-story building. So we can propose to have a double roof on the auditorium building. Okay, next. So this one is the SM7. SM7 is the building user manual, which consists of 1 point. And the table shows the table of content of a building user manual. After we doing all this, we have to prepare one building user manual to gain this point. So next. And then the total point we can gain after the enhancement will be 9 out of 10. Okay, that's all from our group. Thank you.
Okay. I think, let me see. Oh, okay, I'm not muted. For SM, I think it's pretty straightforward lah. Not much of a not much of an issue. I think most of it is either do, like for example, you need a building manual, just provide lah. You need car park, provide. So there's not much of an issue. Yeah, and calculation is fairly simple. So I think okay lah.
I think for me, again, perhaps what you can do, I'm pretty sure you already you spoke to a number of people before you did all this. What would be nice to have is the existing stuff. Meaning to say, how what is the current cleaning procedures? Okay, what are they cleaning with? How are they doing it? Okay, that's one of the examples. Okay, and then at the same time, in terms of the green roof, let's say, the current one, what is it? How it looks like? What's the coverage? And then the new one is, whatever you want to do. Okay, I think just get the old stuff and then include that into your report. Yeah, okay, just a baseline. But to me, all the proposals seems to be okay. The one thing that I might not really agree with is actually the walking tiles,
Oh, yang motion,
the energy tiles.
Yeah,
if you walk on it, you generate electricity. I think that one is not very practical, because we're not in the middle of beautiful city center kind of thing.
Not just that, our maintenance, can they maintain that thing? Yeah, we can't even maintain lifts properly. So
I think you can safely take it out. It's not very practical. Yeah. Okay.
I forgot about that.
Thanks. Okay, can we move on to the next group, please?
All right, thank you.
Who's next? Material, okay.
Okay, you're next. Yeah.
So try to time yourself since you have like 6 sub criteria. Yeah.
I'll go really quick. So good afternoon, everyone. I'm Atika. So me, along with my group mates, Orpita, Lingxin, Janice, Yunwen, Nigel, and we'll be presenting about our proposal on materials and resources. So I'll be skipping this first 2 parts because the other groups has already presented. So I'll be moving towards the proposal right away. So our indicator tool, which is the materials and resources, is highlighting the promotion of the use of environmental friendly materials sourced from sustainable sources and recycling. As well as when it comes to renovation or additional works, we have to have a proper management of the waste. So in terms of proper storage, collection, and disposable of the recyclables. At the same time, the indicator tool as well as have to promote the occupants to recycle, reduce, and reuse, and also the use of green products. So we highlighted the users that we have to deal with in terms of this tool. There's the management. So the management will be managing the policy, the rules, and the contracts to make sure that the waste in the faculty are efficiently managing. And then there's the students and lecturers. Students and lecturers will be the one that use the service that enables them to manage their own waste and materials, as well as to increase the awareness by taking part in activities. And then we have the cleaning management or the janitorial. So they will be the one that interact with the waste materials the most. So they will need to be trained well in order to manage the waste efficiently. So these are the 7 proposals that we'll be proposing. So I will be moving on to the first proposal.
So for the first proposal, we are looking into the MR1's material reuse and selections. We can get the point by using reused material that constitute 20 or more than 20% of the total retrofit material cost. So our next, So our first strategy is using a partition system that made of reused material to replace mature alam bina internal partition wall. And why we choose to retrofit the partition to hit the 20% reused material, because most of the internal wall in mature alam bina are using partition instead of solid wall. And next, what are the reusable material we found? No, previous slide.
Oh, sorry.
And what are the reusable material we found out to construct the partitions? From on-site reusable material, we got the clay bricks, RHS and SHS steel from existing roof steel structures. And from off-site, we found a plastic pallet, timber panel, and reused door and windows. So the image at the bottom left show the existing internal partition wall of mature alam bina. The wall structure and framing system we propose replaced by reused RHS and SHS steel, and the door we replaced by reused door panel. And the image beside show is still the door. When we use the reusable door, is still aesthetic pleasing by using the reused door panel. And next. And for the outer layer of the partitions, we propose to use timber planks and panels that we found off-site. And the image at the right shows how the timber plank can be designed and used for partition boards. And also we found the floating glass on the existing internal partition wall of mature alam bina. So we also propose to replace it by a pendant window that found off-site also. Then the image beside show how it's good using the pendant window. Yeah. Next. So the second, this is the sketches showing how we retrofit the partition by using a reused door and steel as a framing structure. Yeah, next. So the second strategy is during the building retrofittings, we propose to use reusable timber and steel formworks. They're able to reduce approximately 20% total structural cost, and the initial cost of the formwork material will drop to 40% after 4-time reuse. Okay, next.
So for MR2 recycle content material, maximum 1 point we can gain when we recycle content material consists more than 20%, 20 or more than 20% of the total retrofit material cost. So for example, if we're going to do the renovation of some part of the mature alam bina and the retrofit cost is like, for example, 100 ringgit, which means 20 ringgit we must consist of the recycled content material. And then the next. The first strategy from us is retrofit the current exterior wall by recycled material, as we found the existing facade having a big gaps in between the lower, and then that caused the excess sunlight penetration into building. This image is showing the BQ of the external wall part. So as per observed, there are 2 main material. One is the clay bricks and another one is the aluminium sun shading. Next. So therefore, we propose to invent a new facade by focusing on these two main materials and further replace it with recycled content material. So for the first one is the aluminium part. We can reclaim the steel framing and timber plank from other local construction sites and then further redesign and integrate into the existing facade. While to replace the clay bricks, we can use we can use the green mix concrete block that made from recycled concrete and aggregate to function as the exterior wall. So by tackle the two main material of external wall, so eventually 20% from the retrofit cost will be achieved by using the recycled content material. But then currently we're still trying to get the full BQ cost to justify all this calculation. Yeah. Next. Opita?
Sorry, I was just mute. So under the third one, we have MR3, sustainable timber, and MR4, sustainable purchasing policy. So sustainable timber, the 75% or more the wood-based materials and products used in the retrofit should be certified by NTC and FSC. Also, you have to be environmentally responsible considering forest management, and also some of the green products should be ISO certified. And under the MR4 sustainable purchasing policy, we have to take note of the product supply chain to maintain a sustainable purchasing policy under the management control of Metro Alumbrina. Next. So our strategy number one under this MR3 is glue laminated bamboo, known as GlueBAM, usage for future renovation, because under MR1 and MR2, we already proposed the recycled timber. So we wanted to look at alternative option under NTC certified wood-based material. So GlueBAM is a really good option because actually it's produced from raw bamboo, which grows 10 times faster than wood. And then it's comparable in strength to concrete and steel. Of course, it's 30 to 50% lighter than oak. And it's 5% less moisture absorption rate. And also it's less prone to fungus and insects, etc. Next.
2 minutes left. Thank you.
Thank you, Raina. So this is the process of GlueBAM production. The interesting thing about GlueBAM production is actually you can see from the data that for 100 finished boards, the electricity required is 4,367 kilowatt, and also the bamboo waste is 13,500. But interesting fact is the bamboo waste, it is biodegradable, and also if it's correctly treated, actually more bamboo can grow from the waste. So these are the more data about the product produced in Malaysia locally. Next. So these are few graphs calculated the production energy consumption of GlueBAM and other convention material. As you can see, GlueBAM has about 2.7 gigajoule per meter cube compared to steel, which is 448. And another is carbon emission of GlueBAM compared to the other conventional material, which is actually significantly lower than the steel, aluminum, or cement. Next. Next. So because currently, previous one, currently in Machu, two timber usage, there is only one timber usage in the auditorium stage flooring. So we are proposing GlueBAM usage for the auditorium. We can use it for ceiling work or sound insulation or for other walls, stage and regular flooring, and audience chairs and other furnitures. These are two auditorium and the outdoor amphitheater. Next. So under the sustainable purchase policy development, we are proposing three green product purchasing. First one is the thermal insulation roof coating, which is
which is actually a ceramic beads layer above the concrete roof. Of course, it's 84% solar reflectance and 90% emissivity and 96% UV resistance. Actually, the purpose of having this roof is to make it more energy efficient for the building. So when this kind of roof is used, the air conditioner has to work lesser compared to when it's not used. So actually, it's a comparatively expensive option, but it will pay off the cost in the long run. Next.
Time's up, yeah. Thank you.
Do I continue? Okay, I'll just quickly summarize. So we have the active cooling effect for the facade, because currently Marchu's facade is all gray. So we are proposing this nano filter paint layer. You can see the infrared camera image that shows that white radiative paint, it can stay cooler in direct sunlight compared with other commercial paint. Next. Next. So this is actually experimental product, the NUS novel hydrogel. So because this is for future renovation, we can propose this green product that is developed by the NUS Material Science and Engineering. These are a few benefit of the product. I think I'll just skip this slide so my next one can explain.
Okay, so for this, I will talk about this ML5. We provided 3 strategies, which is the design the recycle bin and suite for the building occupancy, and promote and encourage the recycling with managing a system, propose a recycle area or storage area for the recycled material and waste management. Next. So for the first one, we found there is a few types of existing recycle bins located near to the lift lobbies at every 2 floors of the buildings, and beside there is a DIY recycle bin located near to the student center. But there is no reuse storage that we are gonna propose for the architecture models and materials. So the strategy one is to understand the volume and type of waste that's being generated by the building occupancy, and provide a large capacity of paper recycle bin, as most of the architecture students have more usage on the paper compared to others. So next. To promote and encourage the recycling waste minimized by managing a system, we can have a collaboration with the Zero Waste Campaign, which to help some seminar and lecture by inviting speakers to share the importance of the recycle in daily life, and held some competition for each student giving a period of time to collect the recyclable materials that will be transformed into class fund, and those materials can be reused for resources for other activities, and also held some exhibition to inspire the public. Next. Here's some survey data that we gather from our survey form from 90 students in UN, and this is the result. Next.
As we mentioned, so there's an existing bin in every 2 floors. So we suggested to provide recycle stations for every studio floor from 4th floor to 7th floor, as architecture students will produce more recyclable waste, especially on papers. And we also provide reuse stations for the architectural models and materials at the blue location, where the student can recycle their models here and source for the recyclable materials for their models. Next. We also provide a recycle and food waste stations beside the cafeteria and also the stationery shops, which the recycle waste and food waste will be sent to ZWC, as they not just focus on the recyclable material, they also focus on the provisions and procurements of food, including the aspects of food waste and the food management. Yes. So the below floor plan shows the existing and proposed locations of the recycle center. The existing refuse chamber, which is the 4.5 meter times 3 meters, which only for the general waste, and we now propose a new recyclable storage for the recyclable materials. So it's the great one. Next. So the below floor plan shows the building's entrance and vehicles access point, which is the red line, 130 meters from the entrance, and as well as the occupant access the orange color to the proposed allocation of the storage center for the recyclable and existing general waste. Next. So the recycle facilities in the campus that handle the food waste and recyclable waste is the zero waste campaign, which is 3.2 km away from our faculty. Next. So the waste management plan for construction waste, which are derived from the guideline on construction waste management, which they suggested to have a development plans consisting of waste type, quantity by weight, method of disposal, handling, and transportation procedures, and also organize the waste management plans. And the third one also proposed the method for the reuse, recycling, and disposal during the constructions. Next.
So for our last proposal, in terms of the green products, the intention is for the products for the building to use zero ODP products, so as well as natural agents and environment friendly. So one strategy that we would like to propose is that to create and manage a proper contract between the faculty and the cleaning contractors. So in the contract, it should highlight the use of natural and environmentally friendly cleaning products. So an example would be these, and as well as these are Ecomax, TLC, and Backup, which are biodegradable. And second strategy is that after the contract is agreed, the management should provide trainings for the cleaning management so that they can understand more on the cleaning products. And then the next strategy is that to promote the use of natural and eco-friendly products to both lecturers and students so that they can bring that awareness home. So in conclusion, this is our total points. And yeah, that's it. So this is just our survey. Thank you.
All right, thanks.
I
Yeah, go
think maybe there is a misconception here because MR1 just now when you presented, it looks like you're trying to change the partition of all the studios, right? Correct or not? So, and also you say you want to use the reusable scaffolding, moldings and all that for construction, right?
Correct.
Yeah, but you must understand this 20% of the project retrofit is what are you going to do to achieve your retrofit? For example, if the project you have to add louvers to reduce glare. So those louvers need to comply to MR1, for example. So it's not something macam you are talking about the original construction. Perhaps there's no structural work being done. I think there's a misconception there lah somehow. Okay, MR2 also the same lah. It's 20% of the recyclables and all that. I just want to highlight that we already have some sort of program in the university to under Eco Campus, so perhaps that's also something that you should link to. Yeah, and similar MR3, 75% of use of timber, for example, is just also the same. I mean, like a lot of projects when they do renovation, 75% of this timber may come from furniture. So you are suggesting all the auditorium to be changed to glue lamp seats. And so is that part of the refurbishment? So make sure that everything you do is part of the refurbishment. And usually that's why I said it's very important for you not to work in silo, that you work on your small part, because you have to, how would you know that that is like 20% or 75% of the timber used in the renovation? So you, as a group, you must be knowing roughly lah, not just to say exact, but what is your strategy, as Dr. Azam mentioned it just now. And out of that strategy, what are the recyclable materials? What are the timber materials and stuff, so that you can accurately gauge how much is the percentage. Yeah. With regard to sustainable purchasing policy, it's more of the way that you don't have to purchase any product pun. It's a policy. So you're purchasing product for the sake of purchasing product. If I'm not mistaken just now, you purchase things and whatnot. It's a policy. That means that you tell maybe our Timbalan Dekan Pembangunan and Research saying that, okay, you should do this. You should only buy stuff with green certification, for example. That's a policy. Yeah. On the storage, collection, disposable of recyclables, again, I would like to highlight under Eco Campus, we already are doing some of this. So perhaps a quick call to Dr. Asro's office would show. They even have we have reporting of how much we actually contribute to, because our is part of the Eco Matrix camp. There's like a rating for campuses. So as part of that reporting, they actually measure all our waste and whatnot. So I think it's good to have that lah if you want to apply for GBI. And of course, the last one about my worry about this is that actually cleaning agents very simple. It's just, again, people using the good cleaning agent. Usually the problem with refrigerants is a problem, because not all aircon system can use the non-CFC refrigerant. So there might be need to change some of the condensers and whatnot. So I think you should mention that now. It's just a major, although it seems simple, just use another refrigerant, but is your HVAC system compatible with, and is the current, and what is the current HVAC system's refrigerant? What are the current maintenance scheme using? So those are among the questions that should be asked, basically.
Yeah. The first MR1, MR2 too looks a bit confusing to most. But if you look carefully, it's all about retrofit. So when you say the existing building, if you're trying to do a new part to the building, you're retrofitting, adding to the building or changing something, because there's a project, and just make sure that more than 20% or equal to more than 20% of the project cost too, the material too is comes from certain source, okay, according to MR1, MR2, right? So right now, you don't have to go and demolish something which is already existing in order to do that. If let's say you're proposing something, to me, what you can propose right now is where the recyclable materials can be stored, okay? Because we don't actually have a proper room for that, or proper location to do that. Therefore, perhaps you look into you've identified a location at the back of the building there, but right now it's actually a place where the lorry has to stop and park in order to get stuff in. So perhaps the car shed beside it, with the solar panel on top, that could be changed into a new recycling center. So you propose something, and for that to happen, all of the materials that you want to use, or perhaps only about 20% of it, comes from FSC certified recycled material, that kind of stuff. You get what I mean? And then at the same time, perhaps can there's a new subdivision in the studio. Let's say your studio is too big and you want to do a subdivision. That subdivision too will have to have materials of about 20% coming from FSC or perhaps recyclable material. Previously, we have done subdivision. We have also done the stage in the auditorium. So we have no idea where the materials came from, unless we have the BQ. But I highly doubt that we have the BQ. Jadi right now kan, in your case, you are in a peculiar kind of position. So you have to propose a new addition to the building, and that addition has to meet MR1 and 2. Okay, and then other things is just a matter of policies and whatnot. You just list down Okay, by having a policy, you get the mark already.
Yeah.
And then last but not least, the aircon thing too. You have to check with the current spec. If the current spec can use the better refrigerant, then great, no problem. You can get that mark. Otherwise, it means that you're gonna have to spend nearly $1 million ringgit, just to change all the aircon in order to use the new refrigerant. So there's no point in that in doing that, isn't it? So I need to check whether or not the existing spec can take the new refrigerant. Otherwise, get something which is compatible but good enough lah. Okay, to lessen the amount of global warming potential lah. Okay, water group, please.
I have a question.
Last group, is it? Water group?
Sorry. No, I don't water innovation.
Oh, okay. Oh yeah, innovation.
Atika, what is it you want to ask?
Yeah, I wanted to ask for the refrigerant. Do you know who I can ask? Who I can ask about regarding the AC?
The spec is either in a BQ or perhaps you can also send an email to JPPHB, aircon people. They have all the spec for all the aircon systems.
All right, thank you.
In fact, our own technician, Encik Shidi, should know.
Yeah, I was about to say that to Encik Shidi.
Right?
Because usually he is the one who just fixes all the aircon.
Of course. There's been too many disruptions in terms of aircon, especially at the level 9 and 10.
Yes.
Okay, water.
Okay. Good evening, Dr. Azam and also AR Sali. So my name is Hijasen, you can call me Ryan. So our group will be presenting about water efficiency. Our group members include Ng Yi Jing, Hao Wun Hui, Adriana, Raina, and Ko Jia Sing. So we basically started off with the building info, and we also included some floor plans which we can highlight the existing water tank and also the inlet pipe. So it will benefit us for our calculations and design proposal later. We also highlighted the turfing areas. So because we are proposing water irrigation system into our proposal, so we will be highlighting the areas of the turfing as well for our calculations. So here are the floor plans that we are highlighting, as well as we are also highlighting the toilet areas, which will be important to us for our proposal. Here is the rainfall data that we have collected throughout the year, and we'll be using this for our calculation later. I'm passing this to Raina for the next topic.
All right. So this is just a brief information about water consumption. So what we were provided with was just the water meter reading, a cumulative one, in which we had to kind of estimate roughly. So based on this chart, we realized that, of course, last year, due to the pandemic, people were not really using the building. So the amount of water used is lower than the rest of the years before. And in here, we understand that water meter reading, a meter cube is equivalent to 1,000 liters. So that's about it. And next slide, please. Here is basically just the cost estimation based on this Selangor tariff rate for non-domestic supply, which is about RM1.61. This would help us in our calculation later. So yeah, so maybe we should just move on to the next one.
So for this water efficiency, we have 5 criteria, namely rainwater harvesting, the water recycling, the third one is irrigation for landscaping, the fourth one for fittings, efficient fittings, and the last one will be metering and leaking detection system. Next. So we look at this the 5 criteria lah. The first one is rainwater harvesting. So we propose that we have the rainwater storage on ground level, and what excess water will be how do you say, exit to the water, a fish pond. But based on this calculation, most probably there will be no water that goes to the pond, because our water, correct me if I'm wrong, our water might be used up most of the time, and therefore the tank will be nearly empty all the time. So based on the calculation, Naharim calculations, we just input the data and the roof catchment area, and we get that to improve the water efficiency by at least 30% to get 3 points, we need at least 30 meter cube of water tank. And it doesn't have to be one big tank, it can be separated into 3 tanks. So like one tank which has 10 meter cube size. Next. Okay, so grey water recycling, we use water from the cleaner water, so not including flushings. And the wastewater generated, stated here, will be this one, 19,000 plus meter cube per year. And from there, we take the daily wastewater available, and we want to achieve 2 points for this rating. So therefore, it will be at least 30%. 30% out of this daily is 18,000 plus liter. And from there, we measure the tank size that we need to store the water. But one thing I'm not very sure is that how come the figure became 23%? Is it because due to like leakage and stuff? But and I'm not sure whether this one we can achieve 1 point or 2 point, because we aim for 30%, but the turnout is 23%. So that will be one thing that would be nice to clarify with you, Dr. Azam. Thank you. Next.
So this one is the next criteria, water efficiency in terms of irrigation and landscaping. So what we have proposed is to use rainwater wholly for irrigation. And so based on the previous proposal Adriana did about the rainwater harvest, I'll be using the same tank, and then whatever overflow, including those of storm water, will be passed onto the tank, and then we'll be proposing a drip irrigation system to irrigate the landscape. And not only will this pond becomes like a storage, but also it would also promote other benefits like evaporative cooling. So with a drip irrigation system, we can actually save more than 80% of water. So example, when there isn't any rain, there's probably enough water supply from the rainwater that's been collected. So we would definitely reduce the amount of potable water consumption. Next, please. This is just a screenshot from the WE calculation that we've done, and based on this, we've proposed 100% use of rainwater, so that would give us a GBI score of about 2 points in this case. Yeah, that's all. Next one.
Yeah, hi, Jia Xing here. For the water efficiency fitting, is break to the flow fitting and the fresh fitting. The flow fitting will depends on the flow rate and also the duration of use to control and reduce the water usage. For the basin tap, the shower head and the B-tags will be considered as the flow fitting. For the basin tap, actually we use the self-closing. I propose the self-closing trap with the shorter time to well control the water usage. And then for the shower head, we're using the re-rating and iminer flow shower head with the flow restrictor to control the flow rate, the water flow, so that during the shower area, so that it can reduce the 40+% saving compared with the existing fitting. Next, for the big taps, same as the basin tap, it can be proposed through the self-closing and the sensor feature to reduce the percentage of the water saving. This is the some calculation that I did to achieve more how many percent that can be saving in the water usage. Next,
minutes left.
now is talk about the fresh fitting, which is the water closer and also the urinal. The water closer I propose use the lower capacity fitting, less than 4 liter per fresh, and also the dual fresh feature with the full and also the half fresh. And I proposing using the power fresh toilet other than using the existing gravity flow toilet, so that it can reduce more than 60+% of the saving in 60+% of the water usage. And then for the urinal part, I suggest using the waterless urinal with the manual tap and also the mechanical ball valve. Both of these feature that actually can is the type of the waterless urinal, which the first one will be is very close, so it can like have the less mouth in the toilet. And then the second one will be easiest in the cleaning and the services. And then this is the reduction of the percentage saving in the compared with the existing fitting. Next, this is the calculation that we're using the GPI calculator to generate all the data, so that we can see that we actually get the 40.72% of the percentage reduction in potable water consumption. So at this WE4, we actually earn 2 points compared with the 1 point as the existing. Next, I pass to Ryan.
As for the metering and leakage detection, previously the existing building doesn't have any sub-meters at each floor to monitor the water usage, as well as the EMS system to detect the early leakage. So we are proposing the EMS, the sub-meters to be located at every floor directly to the water fittings to monitor the water usage, as well as the EMS panel to be located at the risers of each floor. And it will be directly linked to the personnel's devices, so that they will get notifications whenever there's early there's like a leakage going on whenever they are. So that will gain us 2 points by implementing these two devices. So we gain for about 11 points from all our proposals so far. Amber.
Okay. This one, by using the GPI water efficiency calculator, we obtain that the annual baseline particular water consumption is 51, about 1 meter cube. So by proposing the water efficient fittings, rainwater recycling, and also the rainwater harvesting, so we managed to reduce the annual particular water consumption to 8,000 meters cube. Next. So, for this WE1 rainwater harvesting, so we can get about 2.37% of 798 meter cube of reduction in total water consumption per year.
Sorry, Amber. I think you're breaking. The mic or the line is breaking. Cannot hear what you said.
Maybe you turn off your video. It'll be better.
Okay. Hello? Can you hear me clearly now?
Yeah, you go on first. You go on first.
Okay, so WE1, the rainwater harvesting, so we can get about 2.37% or 798 meter cube of reduction in potable water consumption per year by proposing the rainwater harvesting system. So for WE2, by proposing the water recycling system, so we can know that the wastewater is recycled from the discharge of heat tap, basin tap, sink tap, elevation tap, and shower. So the result of the amount wastewater recycled is about 4,600 meter cube per year, or can be said as 50%. So for WE3, by applying the water efficient landscaping, so the reduction of annual landscape water requirement for the whole landscape area can be achieved by plant selection or irrigation system, rainwater recycling, and rainwater. For WE4, water efficient fittings in our building. So through our proposal, we managed to achieve by 40%, which the proposal annual potable water consumption is 19,000. Next.
Next. So in terms of the cost breakdown, so it generally separates into three segments, which is a low cost water conservation measure, medium cost, and a high cost conservation measure. So in terms of the low cost, we can have the water saving campaign, create awareness to the student, and then we can constantly check on and detect any leakage on pipes and faucet. And we also discouraging using toilet as an ashtray, which leads to multiple flushing. So we also can set a tag or note to remind to turn off tap upon leaving, and do not let the faucet open while cleaning apparatus and equipment. Do not let the water flowing. And formation of the water saving student society also can help to improve as a low cost water conservation measure. So in terms of the medium cost, we can install the water saving shower heads and install flow restriction on the faucet and taps, and install low and dual mode of toilet flushing. And we can also provide an overflow tank to store the overflow water for usage, and also install a sub-meter to monitor water usage at every floor. So in regarding the high cost water conservation measure, we can install a rainwater collecting downpipes on the roof all around, and also come with the provision of rainwater harvesting tank. And then secondly, we can install we can provide a rainwater harvesting system inclusive of the downpipes, tank, filtration, and pumps. And also we can have the provision of irrigation system with utilizing all the recycled water. So the total cost for all the measure will be 71,400 ringgit to make it all happen. Next. So we're using the figure, then we comes to the ROI calculation. So referring the average cost of water, 1 ringgit and 61 cents per meter cube. So we can get a total, after calculating, we can get a total payback return for rainwater harvesting system is 4.4 years. And for water efficiency fittings will be 0.8 years. But for wastewater recycling system, it will take longer years to get a payback. It's because the system is more expensive, and due to the technicality and the filtration system needed. So it's total we need to get a payback about 8.8 years. Next.
As for the final part, which is the carbon emission based on the water consumption, is that we basically can reduce the amount of potable water up to 35.2% after the implementation of energy saving measures. So basically from here, right, we can basically sum up that by saving that much water, we can also save up to 3,548.90 kg of carbon emissions. So that this is to this approach is to help building occupants and also building designers to visualize their contribution in protecting the mother nature, to educate them on the water efficiency and also the water conservation significance. So that's all from us. Yeah.
Right, thanks. it's quite clear that I think the proposal for the wastewater recycling might not be the best option. Like, it takes too long to get your money back. And then it's kind of elaborate as well. But actually my worry for water system at the building too is the flushing, because right now you should have gone to the toilets and tested and then you find out that almost all the toilets too, whenever you flush, it takes too long for it to stop. Okay, there's so much amount of water going out, right? So perhaps some investment in recalibrating the system, right, so that it doesn't flush so much amount of water, rather than replacing stuff. It's just recalibration. Because most of the water fittings are water saving fittings anyways. It's just that the flushing part, and also when you push the button to the wash and basin tab, even though it's supposed to be water saving, but it's not really, because it flows for too long. Okay, so perhaps we just replace those, but nevertheless for the flushing of the toilets too, it needs to be recalibrated. Otherwise I think everything else seems to be very straightforward lah. Okay, Kita Sali, you want to say anything?
Just I think maybe just two things. One is all your reading water data ni, just do a quick check whether it's the same for electricity, is all for the 3 blocks or just for Earth or for Mercu. We don't know, so maybe a quick call to JPPHB. And the other thing is your rainwater harvesting design. I think doing it underground or a bit lower, then you need a pump to pump, is not so efficient. If you're collecting from the roof, we have level 8 and 9, level 9 and 10, right? Which have their open courtyard in the middle, which perhaps can be utilized for some storage lah. Then you can use it for the planting and whatnot.
Yeah.
So that's a more
those can be small tanks, considering it has to be put onto an existing building. And then what's good about it, you can already straight away use the water for irrigation on that floor.
Exactly.
Plus perhaps having some pipes going down to some of the terraces downstairs. Otherwise just now you mentioned that you can have smaller tanks, so the remainder of the tanks can be on the ground for irrigation of the landscape around the building. So it's not that elaborate, you don't have to really dig a big hole and put your tank in there. I think the last thing we need is to destabilize the soil that we are sitting on.
And create a fish pond pula, tak payahlah.
No need. That was just too elaborate. Okay. All right, thank you. Last group, please.
Okay, wow.
Wait, sorry. Because just now I asked about the water recycling, because we aim for 30%, but
yeah, I know. You're in between. Actually, you can only get 2 points there. With
2 points is the maximum point.
With an addition of 7%, you will get the 3 points. Because it says here it has to be 15%.
Ryan, can you share back the screen?
It has to be more than 30% reduction in order for you to get 3 points.
Yeah.
30% or more. Yeah. Right now you're sitting at 23.3 and just a little bit more lah,
Yeah. And I think
otherwise you can scale down a bit just to meet the target of 2 points.
Or you can check that's why I said check your baseline with JPPHB. I think that if this is for everything, then your savings might be even more. You get what I mean?
Yeah. Correct.
Okay.
All right.
Okay, last one.
Last group, please. Innovation.
Sorry.
Any exciting stuff?
Okay, so I'm Tia. So good evening, everyone. So this is Innovation Group. So I'll begin our presentation. So firstly, we'll try to define how we approach innovation and also environmental initiatives for our part. So what we are looking at is first to try to look at how to obtain exceptional performance in the above requirements presented by other groups. So it's a tall task, but we'll try. So energy efficiency, water efficiency, and all that. And secondly is to try to meet some of the requirements listed here in this table. So we'll move on. So first, because innovation is such a big scope, so we try to come up with a unifying identity for our group. So what we try to look at, since we're trying to push for exceptional performance, is to look at something that goes beyond reducing usage of resources. So what we came up with is a self-sustaining faculty building. So we are centering this around a few goals. First is a self-sustaining water collection system, and also solar energy generation, and also reduction of energy needed to cool off building spaces, and resource generation from waste materials, and lastly, the surrounding landscape and how to drain those elements. So this is our idea. So every surface is a pore, so every surface can generate resources for the building. So these are just a summary of our proposal. So we have herb farming and biosphere, we have a green roof rainwater housing system, we have on-site composting systems, and we have vertical green wall system, and renewable energy, and also electrochromic facade. So this might seem all over the place, but rest assured that we'll try to link it up together piece by piece in our presentation. So we move on to the first one. So vertical green wall and green roof rainwater housing system, these are like two opposites. So how does these two actually relate to each other? Well, let's find out. So these are just a small, sorry, my dog is barking, so there's that. So this is just a small GBI table and an overview of what are the goals that we try to achieve. So we try to achieve minimum EE performance, greenery and roof application with the green roof system, and also rainwater harvesting, water recycling, and lastly we have Iron One innovation. So according to this paper by Water Warriors and also Equal Campus, by this report by them in 2017, rainwater harvesting tanks are installed in all residential colleges and the Faculty of Business and Accountancy and also Academy of Islamic Studies, but FBE is not one of them. So this is why we tried to implement the rainwater harvesting system in FBE, so to try to cater to the high water demand, and also because, yeah, sorry. So this is the rough calculation of the roof area based on the grid dimensions and the average monthly rainfall in Kuala Lumpur. So this is the data, 229 millimeters. So this is how, this is a rough sketch showing how it will be implemented. So it's like a green planter system on the lecturer's floor. Obviously, it's not this major reconstruction. So this is just a concept sketch. And the right section shows the projected area where we try to implement this. So firstly, we need to look at technical viability of this system. So this is a very good example, small scale example. So this is self-sustaining bus stop. So you can see the green roof uses a very lightweight planting mat. But then at the same time, they conceal these rainwater housing tanks in the seating areas and the surrounding planters. So this is something that uses a very small area, but at the same time, it is self-sufficient and it doesn't require additional water sources to irrigate that landscaping area. And secondly, this is a rough overview of a planter system that collects rainwater and also how it works, how rainwater is collected. So you allow rainwater to penetrate through the soil, and you also have a splash block and you let it overflow into the collection pipe. So something that works that way. And this rainwater filtration system is something that we've eliminated after discussion. So this is something that costs quite a bit, and this is also very experimental. So next, how do we store the rainwater being collected by the system? So what we try to use this in conjunction with the vertical green wall is to use those water tanks as something that also absorbs heat and something that tries to maintain thermal comfort by taking away the energy needed to cool off the interior spaces. So this is some of the conceptual sketches. And one very good example of this is a vertical planter that conceals the rainwater housing tank. So these are a series of small tanks that can be arranged along the facade of a building. At the same time, it's concealed within vertical planters. So this is something that achieves both things, which is a vertical green wall system and also a rainwater housing collection system. So what's next for our group moving forward is to try to examine if this is worth the effort. So the rainwater collected, is it enough to cater to the usage of the building's occupants? So this system needs power, and then the other elements of the building also needs power. So how do we try to address this self-sustaining concept moving forward into the energy usage system? I'll pass it on to the next presenter with the BIPV panels. Zach?
So, hi, good evening all. So for the energy, renewable energy part, since our building is our concept is self-sustaining building, so we need energy from the sun. So the PIPV is proposed to supply sufficient energy for the building use. Next. And next. So these are the proposed location. So on the first diagram on the left top, you can see this is the site plan where our building sits, and is facing southwest facade, exposed longer hours to the sunlight. So the first proposal location will be on the office, on the lecture office, which is level 9 and 10, which is protruded out compared to the rest of the facade. So this facade will be as an advantage to gain solar energy. So on the outside, it will be this PV cell, and then internal will be the lecture the office window itself. So the sunlight it's not direct sunlight, but then it has a layer of glare. It has a layer of air gap to it, so it won't be so hot in the office. And then at the same time, it can generate energy through the PV panel. So these are the system component that we need for the solar cell. And then on the rooftop part is also proposed for more energy. Yeah, next. So this is the PV that possible solar panel brand that I researched on. So it's 330 watt power at weak peak, which is the peak. Yeah, the peak energy that can be generated from the PV. And then next. So this is a tabulation from energy consumption from data from our school. And then for this, I use the formula of I tend to get the 6 months of the consumption, and then I average out by dividing into 6, and then this number will be the average per month. And then so by dividing the peak, the watt peak 330, I'll getting we will need 174 panels for a month of consumption. Next. So this is a estimation for per panel. So 1,000 times 1,600 will be the size of the solar panel, and then for every month, the energy can be generated by 260 kilowatt per hour per day. Yeah. Next.
10 minutes left.
Sorry, thank you. So this will be the location proposal. By estimating the facade area to be 230 square meter. So approximately if efficiency is 20% of the solar panel can gain because of the facade, and then it's facing like 4.5 hours a day, so we can generate this number of figure per day on the facade. Yes, next. So on the rooftop part, this is just a fun fact of how many energy can be provided if we go full force, we go full span of the solar panel.
Can you be faster, Zach?
Yeah.
Yeah.
All right. That's all from me, I guess. Next.
All right. Good evening, everyone. Okay, this is electrochromic glaze facade. Yes, this is one of the highest cost proposal, but we only required for 10% of the facade to gain 1 point. Next. Yeah, next. This is like the overall research. Okay. The current issue is the orientation of the building itself, whereby the longitudinal side facing the southwest and also northeast, which is resulting to the glaze. So for the 10% facade requirement, we are proposing that the level 5 will be the floor level that we only use this technology, because level 5 is one of the highest energy consumption in the building. And lastly, the existing coated window is actually minimize the daylighting during the morning and require artificial light to light up the room. Right, next. So this is two electrochromic technology. On the left side is the one that manufactured together with the glass. But on the right side is actually just a film that we can actually apply this to the existing window and does not even need a demolition of the existing window. Yeah. Next.
Time's up.
This is okay. Just a quick one. Okay. This is what I explained before about the daylighting. So we can actually turn on and off according to the needs. Yeah. Next. So this is the product that is actually available in Malaysia, and there's the spec of the product over there. Yeah. Okay. I think next. That's all.
Okay, so now we'll talk about the on-site composting facility, which is under Innovation 1 on on-site composting to achieve recycle landscape and organic waste to meet at least 50% of landscape fertilizer needs. Okay, so what are composting facilities? They are locations where organic municipal solid waste is collected and stored in a controlled setting. And how do we get that waste and what kind of waste that? Organic waste is a leftover food, rotten foods, or mainly just landscape waste that is vastly available in Fakulti Alam Bina. And what's the benefit of on-site composting facility is environmentally responsible by reducing amount of waste going to landfill. And not only that, we can also save and generate money from the composting product and also reduce waste. Next. Okay, so these are these are the composting facility that we have to at least cater 50% of our Mercu Alam Bina landscape. Next. Okay, so one of the nearest example is Zero Waste Campaign. So they have been here since 2010 in and they have until now they have about succeed in converting 1.1 million kilogram of different wastes from landfill with their recycling treatment since 2010. Okay, and so these are, we can make a collaboration with them by learning and also exchanging technologies and knowledge with them. Next. These are the conceptual diagram of on-site composting facility on what is the components of making composting facility, mainly a mature storage and enclosure, production machine, and also a platform for the composting process. Next. Okay, so the proposed system for our Mercu Alam Bina would be box type composting system, which are more practical than typical window system because it is smaller, but it also caters for more composting waste than the typical window system. And next. This is the proposed location of the on-site composting facility. In the picture, it looks quite small, but it's actually enough for a small scale composting facility. And these are the proposed layout plan on how it can be arranged. Next. These are the operational flow on how it would function for an on-site composting facility, mainly the collection of waste, composting of waste, and also marketing, which is actually quite essential for us for the maintenance of the facility itself. Next. And these are the organizational chart, the typical organizational chart for small to medium scale of composting facility. So there are supervisor, assistant plan manager, and also plan manager and also senior management, which can be Fakulti Alam Bina itself, the owner of this facility. Next. So the conclusion is what do we do with it? What is zero waste? So by collecting organic waste and then to compost facility, by who we can integrate academic staff and also students as a part of co-curricular activities for this composting facility. And but the main body will be the management itself and also the cleaning contractor. And then the result will be a zero waste community resulted from GBI rating tool. That's all. Thank you. Next.
So next, the proposal for herb garden and biosphere. So this is focus at the area of the outdoor amphitheater in front of the Masjid Al-Bina. So it's actually a extension from the composting facility where we can actually further use the composting facility on this proposal to do the landscape. So next. So for herb garden, this is the current situation where the area that highlighted is actually as a student of FBA, we can notice that actually this area is actually not very user friendly because it always exposed to the harsh sunlight, and also it is useless that the student doesn't use that much. So we are trying to propose to how to revitalize this area so that it can actually promote some benefit for the user of the Masjid Al-Bina. So next. So this is the proposal sketches of the biosphere and also the herb gardens. So we can separate this into two areas. So the aromatic herb garden is focused on the gazebo area where the people can actually go and enjoy the aroma, the sense of smell, and while resting at the gazebo. And for the educational herb gardens, it actually can also be the another activities for the architecture student. It can be the practical and interactive experience for the landscape courses. So it is an extension of the teaching to the outdoor teaching environment, and the GPI calculation to hit this, we need at least 10% of the landscape area to be the herb gardens, and after calculating the herb garden area, it's actually covered 29.5% of the total area. So it gains a mark for this. Next. So this is some proposal of the plants.
Sorry, how large is your area again?
182 meters square. We use
182, okay. Thanks.
100 something of the area.
182 meters square?
Yeah, because we also include some sitting areas, some walking areas.
Okay.
So next, this is some proposal of the plant that we can plant, which is very common and is as easily get, and it also can be a material for the cafeteria to do their cooking as the attention to these users, or it can be the collaboration with the zero waste to help some events to sell all this organic food. And the hardscape material is the grass concrete pavement and also comparative concrete rock, which is like easily get, and also it is comparable to the rainfall, so it actually can link to the biosphere, which will be explained by my group later. So next. So this is example of how the herb garden can be easily done using the simple materials, the concrete blocks, the newspaper at the base for the soil itself. So next.
Okay.
So this is planting information on how to calculate how many plants to be planted based on the space between the plants, and also how many soil roughly calculated based on the calculator. So for the report, I will list out the more detailed parts about the plants itself. So next.
Yeah, so thank you, Nicole. I will be continuing on the implementation of the biosphere on the surrounding area of the faculty built environment. So there are four main benefits of integrated landscape, and the biosphere which would be aiding in the better stormwater management, flexible application where it can be implemented in any number of geographical area, reducing the maintenance of the stormwater systems, and also will be more aesthetically pleasing compared to the conventional drainage. So from the GBI requirement, in order to be listed under the innovation section, the biosphere must be more than 25% of the building parameter. So we did an estimated calculation where we can get about 67% of the total coverage of the biosphere, which can be implemented at the surrounding area. So next. So by activating this amphitheater, it is to attract more users to engage with the spaces. And greeneries are introduced to provide shading where it can be doubled as a buffer space between the steps. So with our current cracked pavement can be replaced with the porous pavement with turfing, which can also aid in the diversion of the stormwater. Next. So to look into more detail, the collected runoff water can also be used for the irrigation for the surrounding landscape. Creepers are also proposed to further greenify the area as well as reducing the heat gain. Next. So the detailing of this is the detailing of the biosphere and to show how it works. So thank you. Next.
Yeah, that's all. Thank you.
Thank you.
That's all done.
Yeah.
How many innovations? Seven.
We have
7.
Okay, my biggest problem is with your BIPV lah. Because first, it's not BIPV, it's just PV.
Yeah.
BIPV is not integrated into the building. And worst of all is PV or BIPV is not an innovation under GBI. It is captured under energy efficiency only. So you cannot count it as an innovation point. Yeah. And thirdly, your energy calculation just now with regards to consumption and is it tally with the others? Is the same? Or is your own? Because it looks like different. It should be the same, right? You see, you're doing the same building, right?
Not sure about that, but Dr. Azam, I think I asked about is PV fall under innovation, right? So that's why I continue to.
If it's semi-transparent PV, then perhaps lah kan, you know. Right.
Yeah.
Now it's just normal PV. Then there's nothing special about it.
I propose on the facade, so the sun shield can penetrate through the facade.
No, okay. This is information for everybody lah. You know that the innovation is already listed in the guidebook, right? At the edge, right? But also, if you go to the GBI website, there is a list. They call it FAQ. There's a list of innovations there. So you could just pick out anything. And I think, Zach, you can just change yours to solar thermal or solar aircon or whatever, which is a valid innovation.
All right. Noted.
Yeah, so it's easier than,
I think perhaps the other thing is the composting thing, you know, the composting thing though, the location I think might not be very appropriate. You could bring it closer to where the current rubbish bin is, or perhaps, you know, you go and plonk it where you have your herb garden lah kan, you know. So you've got your herb garden there, then have your composting facility over there. And then for your information, on the 9th floor to where the existing garden is, kan, you know, there are already I think 2 or 3 composting pits there existing. Okay, so there's some compost in there, some worms and whatnot. It's been in use for the past year and a half, okay, about 2 years now. So something for you to look at lah, kan. Okay, that one is on an existing building, right?
Yeah.
So
maybe we can incorporate. Maybe we can incorporate that to
that one is already sitting there. You can't do much about it anymore. I think perhaps, you know, you can learn from it by incorporating it into your own herb garden rather than putting it isolated away somewhere else. Yes, there might be some smell here and there, but that's part of the fun, kan, you know. So why not? And then, you know, perhaps you could look into helping out the material group by using materials which are recycled and whatnot, kan, you know, so that they can achieve MR1 as well. So talk to them, okay? And then the other thing is the ZWC. We are already totally synchronized with ZWC. So you can call them up and ask how much amount of waste that we give them every single month. They will have the data, you know. So organic, non-organic, semuanya dah ada, you know. And then we do recycling as well. So sometimes ZWC did get all of the stuff, but sometimes they don't get because our cleaners they go and sell it somewhere else. Jadi another source of data will be our own deputy development. Okay, so ask from him lah kan, he might have some data as well. Jadi need to correct yang tu lah. Okay.
Alright.
Yeah.
Thank you.
Maybe just for information lah, some easy innovations are in the real world, right? It's universal design.
Yeah, of course.
Compliance to 1184 is almost like a free point lah for innovation. Simple things like waterless urinals, they are still considered innovation because the definition of innovation is something that is not commonplace in the industry or in Malaysia. So if it's unique, then it can be considered innovation. If it's not under the list of the FAQ list or the GBI list, it will be on a case to case basis lah. But if your thing is very common, like solar, it's very common now. So that's why they no longer consider it innovation from I think about 2012 or 13 like that. Yeah.
You see your the water group earlier on presented the waterless urinal. You could take that away from them and use it as an innovation. But you have to make sure that it's good by making sure that the amount of ventilation or not is good enough. Otherwise you get very smelly toilets. Okay. Thank you very much, Architect Sali. It's been a really, really long afternoon. A lot of good discussion, and then I think the students have already produced much of the things that we have required them to do. Please do make the amendments and correct some of the mistakes and whatnot, and then submit it on the 29th. Okay. So for today's exercise, you just upload everything into Spectrum. Otherwise, I think if you have a problem with Spectrum, just email your slides to me. Okay. As is, you don't have to change anything. All right. Okay. All right, guys. Thank you very much.
Thank you, Dr. Azam, for inviting. Okay.
Thank you so much.
Bye.
Thank you. Thank you.
Thank you.
Charlie.
Take care. Stay safe.
Okay, stay safe, of course.